Hello.
Hey, Ethan, what's going on?
I haven't been on in a while. How's it going? How's everything been going?
Good, man. 1 sec.
Hold on, Dr. Cole. Are you giving out prices to the top 10?
No, read the rules. Top 8.
Top 8, sorry. I meant top 8. Sorry, my bad.
Well, the prizes don't go to the top 8. They're just in the drawing.
Okay, well, I'll still try. I mean, Dr. Cole, I still got down a point, so I'll just go in for the draw. I'll at least try.
Well, yeah, those don't get put in for this drawing. I can't add those right now. I said you had until noon. You had until noon today to process them. It's okay.
Honestly, I don't really care. But
Okay.
could those be used for next
Yeah. Everything's you. Yeah, we're still doing the regular tournament for the rest of the semester. It's just the first week I wanted to give everyone kind of an opportunity to well, people who had a bunch of channel points saved up from watching the stream for the last year, I wanted to give them an opportunity to basically dump most of their points. I know Sam only dumped half of his, but
Yep, literally.
to dump most of them so that it's fair for all the new people coming in. But I also still want to give prizes out.
What's up, Dr. Cole?
Shrey would have gotten yeah,
something.
maybe, but yeah, again, this is why I always tell everyone to like read the rules. Like I very clearly put out what the rules are for things, so please read the rules. I had none, by the way, so nobody say I was saving. Yeah, well, we thought you were at some point, Obama. Anyways, okay. Yes, we got a lot of people here. Wow, what's up, Nick? What's going on, dude? Yeah, I got your last 250. All right, let me do the prize drawing because I know we got a bunch of questions today for homework and stuff. Let's see. Let's kick it off. All right. Welcome everyone to Office Hours. My name is Dr. Cole. It's Actual Education. The stream will help you out math, homework, science homework. All sorts of fun stuff. Yeah. So we started our spring semester tournament last week, and this first week was orientation, just so everyone could kind of get a feel for how the server works, how you get points, how you complete challenges, how you can place. I'm glad we had a lot of people. I think we had like 56 people participate or something. There was a lot of people. So what we're gonna do is we're gonna do a drawing for the top 8 so far. So this is kind of similar to how it's gonna work for the main tournament, except I think that one's gonna be top 6. So and just the things we had this week, which I think was like Fortnite Jackbox, dailies, what was it, office hours questions. That's just the baseline challenges. We're going to have more challenges pop up. There'll be more opportunities for you to earn coins and stuff. So always, pay attention to, I have this channel here called, so if you're in the tournament, there's a whole channel here called, Read Here First. This will have all the announcements of the updates of what happens in the tournament. So a lot of you guys did read this. I appreciate that. It's very smart of you guys to do that. And then here, empty announcements. This is where the only channel you can do the daily challenge. Which, the reason why I have this is because anytime I have something immediate, it will get stickied and posted here. So you will see this. Okay. Let's see why is everyone obsessed with cats? I don't know, it's the internet. Of course everyone's obsessed with cats. Okay. So, if I look at the totals, we're going to have the top 8 who are going to be eligible for prizes. We're going to give out 4 series of prizes. Okay, so how this works is I'm going to go to picker wheel here. And whatever these scores are, that's the number of, entries you get into the drawing, per se. Okay? So, the first one we have Playmowats. And Playmowats has a grand total of 32,156. Congrats, Sam. Some of you may be wondering, how does Sam have so many points? It's because Sam has a lot of channel points. So on this Twitch, if you watch the streams, if you come to, I think if you have a streak, right? If you keep coming to streams and there's a streak, you get more channel points. And then if you raid, if you raid other channels, you also get bonuses. So this is why it helps to watch the Twitch, because that enables you to buy MT coins here through the stream, which is another way to increase your chances of winning. No, Shaq, you can't daily yet. No one read the fucking directions? Oh my god.
No one.
Jesus Christ. I'm going to start putting more things in the directions that reward people that read the directions.
Please.
It's like the whole reason I have the front office. It says like, please say, if you say coin please, you get a coin, because no one reads the directions. I'm like, well, if you read directions, I get it. When I was in school, our teacher used to do things where, she said, read the directions at the top, and no one would do it. But at the top, it said, if you've read the directions and you write your name and put a check mark here, you can just turn the test in and get 100. And it was so funny that no one did it because no one reads the directions.
Yeah.
So I don't know. I'm trying to. Wait, tech support is Taco Cat, right?
Yeah.
Okay. All right. So we have Nick with 16,866. We got Taco Cat with 14,966.
Nice.
Then we got, let's see, Teacup. The infamous Teacup.
It's funny. Yeah. If I had 7 more channel points, I would have had another 250.
Well, you were smart. You at least you did buy yours off hours, which you can do as well. I forgot that you could do that, and I made that an announcement in the thing. Okay, we got all right. So good job, Teacup with 11,847. Jamarcus with 11,402. Wow, y'all were actually pretty close on a lot of these. That's good. I like to see that. I like to see that it's close. Good. Equity.
Sam is like, I used only half of my channel points.
I know. Sam, please don't dump the other half during the tournament. That's the whole point of this. Is I want it to be fair going in for everyone else. Not your friend with 10,936.
Bro's like, I got another 30K.
I know. God damn it, Sam. I may put restrictions on that. So if you really wanted to, this was the only time I allowed there to be no restrictions on using channel points. I may put restrictions, like anything with any game. Things get nerfed eventually. I do have to nerf certain things if I see they're just getting abused.
Maybe once a day or something.
Yeah, well, it's similar to for instance, the weekly question credit. You can only get that once per week. Because I know not every student can make every single office hour stream we have during the week, but I hope you can make it at least one. So that's why we stream 3 different times, 3 times a week, and you don't have to worry about showing up to every stream. If you show up to every stream, you get more channel points, which enables you to buy more MT coins. But the big bonus for the questions, you only got to do once a week. It's the same thing with the recess games. You only got to do it once per weekend. We do a time on Saturday and a time on Sunday. So, nice. And Jarbeefus, scooching in there with 10,013 is going to be our last person to qualify for this. Okay. There we go. Cool. All right, sorry. Let me read the chat real quick. We raid homeless people. What do you mean we raid homeless people? What? I can't even do the master tournament this week now. And it's also okay. This is why the tournament lasts for 3 months. If you miss a week, it's not the end of the world. You're not going to, be completely out of the running because we have challenges every week, Now, if someone's doing everything every single week, yeah, they're probably going to win. And again, I want to reward that. If you participate the most and you complete the challenges, then you should have the best chance of winning. So that's just how life works.
Teacup's like, if it's Nick, I want to respin.
If it's Nick, I want to respin. Yeah, right.
Yo, Gold, what are the restrictions? I wasn't paying attention.
What are the I don't know. I haven't put in restrictions on redemptions yet. But if I see they're becoming a problem, I will. Just know that there were no restrictions during orientation week. I told everyone there's no restrictions. So if you had channel points and you wanted to dump them, this was the time to dump them.
Everybody got to hear this, bro. I don't have anything saved.
All right,
nothing.
Okay. All right.
Nothing. So they don't say I'd be saving 100K. I got nothing. I started from
I know.
Where's your proof?
I know.
Where's my proof?
Yeah.
You want me to send you a screenshot? Well, I have a decent amount now, but
okay. Yeah, and that's fine.
It's just 1.7K.
Yeah, it's okay. You can again, if you accumulated channel points during orientation week and you didn't want to spend them during orientation week, that's all right. Like, okay, you can. Again, I can't force you to use them. I'm trying to incentivize you to use them with the drawing here. So okay, let's see. What did I say the prizes were for the week one? Oh, here we go. So $50, $30, $15, $10. Which order do you guys want me to go? Do you guys want to go high to low or low to high? Like, should I
High
do?
to low.
You want to go? Someone says low.
Well, why am I even saying this? I'm just
Jacob
saying.
says-
Jamarcus like low to high.
Low to high?
He's gonna get freaking 100.
Low to high? Okay, we're gonna do low to high. Okay, all right, we'll do low to high. I think they do that in like celebration things, right? They're like 5th place, 4th place, 3rd place, 2nd place. Okay, yeah. I don't know what the psychology. Whoever's a psychology major, tell me what the difference is. All right, so this is going to be for the 4th place prize, which is a $10 gift card. Let's spin and see who gets it. Is this to see if like?
Sam, I feel bad for you.
Oh wait, actually, wait. One sec. I can't do that because wait. Low to high.
Come on.
No, because that doesn't make sense. Because if we do low to high, then if you have the best chance, you have the chance of you have the best chance of getting the lowest one.
Sam's gonna
No,
get
no, we don't want to do that. Oh my, you guys trying to trick me here? No,
Yo, Jamarcus, bro.
no, it's
That's
got to be
ridiculous.
that. No, it can't be low to high.
What?
If everyone had an equal chance, it could be low to high. But sorry, yeah. Dude, this is why it's Monday.
Jamarcus, bro. What the hell?
Yes. No, yeah. Okay, yeah, no. Thank God. 'cause, yeah.
Sam's gonna get $10.
It has to be high to low because if you have the most entries, you need to have the best chance of getting the best prize. Yes. Okay. One sec. Now I gotta. Okay, but I can't.
Who won? I wanna see.
No, I'm not gonna show you. I'm not gonna show you. I'm not gonna show you who won. I'm not gonna show you. Okay. All right. It is high to low. That's what it's supposed to be. Yes. Okay. All right. Here we go. All right. We're gonna spin.
Who won though?
I'm not gonna say.
And
Sam,
probably not.
There we
Sam.
go. Sam gets it.
there you go.
Congrats, Sam. All right. Play Moets is in first. All right, here. I'll let me put these in. Okay, so first went to Play Moets. Okay. And then what happens is we take Play Moets' entries out. So now this is the new drawing. Okay. All right. I mean, yeah, and not a surprise because yeah, and to be honest, when I did roll it the first time, Sam didn't get it. So it's chance based. It is chance based. Yeah. But as you see, if you have more points, you have a better chance of winning. Yeah, I'll tell you at the end who the first one actually was. But then again, they would have gotten the low. So right, it's kind of unfair. All right, here we go. Next, second place. Who's gonna get second? Taco Cat.
No
Nice.
way.
Second place. Good job. Oh, 1 sec. Yeah, is there echoing on the Discord because I know why this is working. 1 sec.
Yeah.
Yeah, you guys gotta tell me that. Sorry.
So close to me.
Sorry, it's this. There you go. Okay, there you go. All right, sorry. It had the okay. All right, so second place is now gonna go to Taco Cat. Okay, cool. All right, now we take Taco Cat's entries out. Third place. Goes to Jarbifus.
It's quite interesting.
We're like Jamarcus Cousins or something.
Is it Jamarcus's cousins just because it says Jarbifus?
Yo.
Yeah. What did you win? You won third, dude. You won third. Okay, cool. Jarbifus. Nice. All right. Last drawing. We are no longer. Yeah. Teacup says, Nick, our spinner wheel reign has ended. Yeah.
Shit. Yo, I want $10, please. Oh.
Who's it going to? It goes to Teacup. What's even the prize? $10. Yeah, there you go. There's your Discord Nitro. Didn't you want Discord Nitro, Teacup? There's Nitro.
Rob Children.
Yeah, nice. Okay, cool. Yes. Yeah, good. Thank you. Yeah, and I appreciate the good sportsmanship. Yeah, that's good. Yeah. Steal a child for more. Okay. Okay. Cool. All right. Thanks. All right. So that's how the drawing is going to work at the end of the tournament, which is I think in April. So you want to try to place. I think we're going to do placement for top 6. If we have more prizes, which I have been having a bunch of people reach out to me saying that they have, like, for instance, keyboards or extra like webcams or headphones and whatnot. If we have a bunch of prizes, I'll open the spread. I'll open the spread to more people. I'm just going to guarantee top 6 for now. But if we have more, there's always going to be more prizes. So, try to do your best in the tournament. Yes. Okay, cool. All right. Yeah, when I first spun it, it was Equity. Equity is who it was when I had spun it the first time.
That's crazy.
Yeah. Anyways, I was just like, uh-oh. Okay, cool. All right. Yes. Okay, and then so now what I'm going to do is let me open up the dailies for you guys. So, one sec.
So it's day 1, right? Or
Well, so what we're gonna do is we're gonna reset the economy. So yeah, I'll show you how that works. So everyone's coins are going to reset. So I know you probably were like, oh no, what's happening here? But that was because the first week was for everyone to get a feel for how this works, right? I need cocaine somehow. Stop, Marcus. All right. Okay, so we're gonna reset. So everyone's gonna lose their coins. It's okay. You all did very well. Great job on the first week. This resets, and now dailies are re-enabled. I'm curious if the streaks still work.
I'm gonna test it right now.
Yeah, test if the streaks still work. I wonder if the streaks carried over. But
Command is disabled. Huh? Oh, wrong channel.
Yeah, it shouldn't be disabled.
Yeah, dailies. The streak is still going.
Oh, the streaks still work? Okay, cool.
Yeah.
All right, that's fine. Whatever. Y'all can still get the bonuses for the streaks. Okay.
That's okay.
Cool. Okay. So yeah, tournament starting. I'll make an announcement about it later today. This first week was good for you guys to, get a feel for how it works. Yes, there you go. Yeah, there you go. And yes, you guys can all start doing all the things. Yeah.
All the things.
Dark is still echoing? I don't think he is. You let me know.
I am. I heard it many times.
Really? Why is it doing that?
I like how I'm 10th place and 3rd place at the same time.
Oh, it's still sharing my system audio. No, stop sharing my system audio. Well, one sec. Let me stop streaming this. Let me share my screen again. One sec. There we go. Okay. Cool. Has anyone found a way to game the system yet? Yeah, I mean, so Penn Center, the students are students. They're our kids. I get it. And so we've luckily ran this tournament a couple times. It's not our first rodeo. This is probably the 4th or 5th one we've ran. So at this point, I kind of know where kids will try to find like exploits and cheats and stuff. And we know how to deal with those. Yeah. Do binary, I guess.
Yeah. I gave myself 100 bond coins, yo.
Yeah, because something was broken with the other server. Yeah. In that closet he's in. Yeah, don't do it to me, please. Don't. Take gold hostage. Yeah.
What, bro?
Yeah.
You better give me gift
Okay.
cards or I'm gonna pay you.
All right. Let's start off office hours now with questions and stuff. Let's see who is first. Not your friend. Are you here? You here? Not your friend. Let me delete. Well, actually, I'll leave this up. Yes. Okay. Cool. We're gonna do yours first. Do you still need help with this one? Do you still need help with this geometry question?
Quick question.
What's up, Nick?
Can you now get points, the MT coins for questions? Or not?
Yes. Also, yeah. So now, so everything is reset for. Also, this will reset every week. So every week will be a new week for you to get credit for asking a question. You just have to do it once during the week. And then the gaming credit has always also changed. You can always find out if you have it or not. Just look at your roles. If you have weekly question, it means you got the weekly question credit. If you have the weekend warrior role, that means you got credit for playing one of the games on the weekends.
Mm-hmm.
Yeah, the trial thing is for new people. It ended, so now it's the real thing. Correct. Yes. Yeah. What's up?
I also want to ask a question.
Okay, what question do you want to ask? Is it about this or something? What is it? What's your question?
Different question. Someone
what's
else's
up?
question actually.
What's up?
I feel like I feel like equity's question is kind of similar to what I'll be taking. It's like I've learned how to find the area of a segment or a sector.
Oh, okay. Yeah.
I have a quiz coming on that soon, like on Wednesday.
Okay.
I
Yeah,
need
we'll
help
do
with
it.
that.
Yeah, we'll do it. We'll do
Just
it.
I feel like I'm experienced with this, and I just want to make sure.
Okay. Yeah, we'll double check for you, Ethan. All good. Okay.
Later then.
Yeah. Let me help out. Not your friend with this one. Okay. ABCD is shown the figure to be a parallelogram. Okay. So what is it? This thing is a parallelogram. Okay. Why is everyone calling me today? Stop. Cool. Parallelogram means this is equal to this, right? And then this whole thing is equal to this. No. Okay. E is a point on CD shown in the figure. The CD has been drawn parallel to F. Wait, what? CD has been drawn parallel to F such that DF is equal to CE. DF is equal. Oh, okay. Okay, so they want to say this is equal. Sorry, these things are parallel. Well, also, parallelograms are equal. They're equal and parallel, the sides. Okay. And AD is produced, and the straight line through F parallel to AD to meet BE produced at G. Oh my god, what's all this stuff? Okay, whatever. Okay. Show that the triangle's ADF. Here, we're just gonna try to prove this, and then I'll see what of this stuff we actually need. ADF and BCE are congruent. Okay, cool. So we're trying to show, what is it, this one? And BCE. Oh, okay, and this one. Okay. That's not bad. Okay. What's up, Half Alpha? Okay. Not your friend. Do you know how you think we would start this one? It's probably good to like write down the given stuff. Let's write down the givens. I like to see what the strategy is. So if I'm trying to prove that this triangle is equal to this triangle, I probably want to use one of these things. Either like angle, side angle, side angle, side, 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 or angle, angle, angle. For those that haven't taken geometry yet, or maybe you forgot, these are the rules of how you can prove that two triangles are basically the same triangle. If you can show, for instance, within a triangle that you have an angle and a side and an angle that are the same on both, then they're the same triangle. If you can do a side, then an angle, then a side, they're the same triangle. If you can prove all the sides are the same, it's the same triangle. And if you can prove all the angles are the same, it's the same triangle. Although, so this one is, this is that they're similar, right? This isn't that they're congruent. This is that they're similar. But I think these are all that it could be congruent. Congruent means exactly the same. Similar just means, like, has proportional sides and stuff. Sam, we already did the spin. You won.
That's dope.
Yeah. You're good. Okay. So if I need ADF here to equal BCE, let's try to see if we can get some sides and some angles the same. So from the givens here, they already tell us that DF is equal to CE, which is nice.
Nice.
Because that's already one side of the triangle on each, right? So I can say that DF is equal to CE, and that's given. Even more so, I know that ABCD is a parallelogram, and in parallelograms, the sides are also congruent. So that tells me that AD is congruent to BC. And that's because we can write this. We could say A, B, C, D is a parallelogram. I don't know. Okay. The next thing we need to do is to get. Oh, we could either get another side or we could get an angle. Okay. What do I want to do here? What do I want to do? Oh, you know what I can do? Okay. Yeah, here's what we're gonna do. I see something that we can do with because these are collinear. So first of all, I'm pretty sure that this angle and this angle have to add up to 180. I think, is that true for a parallelogram, that these angles have to add up to 180? I think if we do like, yes, yeah. Right, okay. So if this and this have to add up to 180, then, also, okay, this is dumb, sorry. This is equal to this, right? Because this is a parallel line and this is a transversal, okay? And then I believe this is equal to this. Because they're opposite. Are opposite angles of a parallelogram the same? Yeah. Let me make sure that that's correct. Again, this is the part of geometry, like, I don't remember all the toolbox. I don't remember all the rules. Opposite angles, parallelogram. Are they? Yes, are equal. Consecutive angles add up to 180. Cool. That's all we need to know. Okay, great. All right, we got this. This is easy. Easy mode. Okay. So, whatever. We can say DC is parallel to AB. And then what? You just this shit. So then, angle DAB is equal to angle ADF. And that's opposite interior angles. Cool. And then I can say that oh, even cooler here. Yeah. I can say this is equal to this. Oh wait, no, that's not what I want yet. One sec. This is equal to this. Great. This plus this is 180. Okay. Yeah, here we go. Was it? DAB plus ADC is equal to 180. Thanks. Oh, thanks for the follow, dude. What's good? Yo, what's good, Ian Stuckey? Back from your vacation? I think I saw you were streaming earlier. And what this is, blah, blah, blah. What did they call that? Sorry, they said that. Oh, consecutive angles are supplementary. So consec angles are supplementary. Cool, which also means this plus this is 180. So also going to say the angle BCD. Ooh, I like BCD. BCD is a nice tofu place in LA. I had that for late night food on Saturday. BCDs plus what is this? ADC. It's also equal to 180. Same thing. So since these things are the same, right? That means that angle DAB is equal to angle BCD, which I think do we call that like the subtraction property? I think we call that the subtraction property, right? For the formal geometry proof, right? If I say this plus this is 180 and this plus this is 180 and these two things are the same, I think we can say like subtraction. Oh, new attention to prosopon. That's cool. Oh, group theory. That's cool. Yeah, good stuff. Aren't I too old to dab? What type of dabbing are we talking about, though? Right? There's this dab, you know? And then there's what my friend calls, like, the Mad Max shit of weed, which is, right, just doing sheets and stuff. I don't like that either. Okay, cool. Okay, and then, so, look, you're not your friend. If I have a side, angle, side, and this one is a side, angle, or wait, it's side, angle, side, then these two are congruent. Yeah, so cool. So then, yeah. So then, what? ADF is equal to angle BCE by side, angle, side, and you're done. Nice. Sup, I went away and now there's a different streamer on my screen. That's too funny. Oh, because you got... Oh, thanks for the raid, Ian Stuckey. I didn't even notice that. Sorry. I got so many things coming into my feed. Yes. Hi there. Yes, you got rated. Yes. I'm another math streamer. We have a bunch of fun math streamers here. Here, math streamers. There you go. Those are all the Twitch streamers that do free math and science help, and so yeah, follow them. They're great. Yeah, cool. Okay, cool. All right. Was that it? Was that? Give reasons why ABEF and AGHF are parallelograms. And why their areas are equal? Oh, okay. Here, I'll leave you to do that one because I've got a lot of questions I got to go through. But hopefully this one here helps you out. It's gonna be a similar strat for it. Yeah, if I have time, I'll come back and do the other one. But here, let's at least we got the first part done for you. So not your friend. 3. Cool. Nice. Okay. There you go. And then here, let me give you, what was it? Give coins at not your friend 1,000. You're very welcome, dude. Okay, nice. Amount 1, not your friend. Cool, awesome. Okay, next question is Equity. Equity, what's up? You in the chat, Equity?
If he isn't here, then I could help.
Yeah, you can help with this one if you want. Yeah, this could be a good question. Okay, let's do it. Okay, circles. We love circles. Circle theorems seriously like scare me, dude. Because there's so many weird ones. This is luckily kind of not that bad of one. Yeah, thanks for the follow Alex, dude. Dope. Okay.
Find the area of like a segment.
Yeah, well, they want the area of this. They want the area of this shaded region right here. That's what they want.
Is that a sector or a segment?
Is it a sector? I think it's a sector, maybe. I mean, the segment, I think, is this. The sector, I think, is... Well, wait, the sector is the whole thing, I believe, right? Is that what we call, like, area of a sector? Yeah. Yeah, the sector is the whole thing.
All right.
Yeah.
So then that must be a segment of the thing.
Well, they want us to find the area of this. This is like a subsector, I guess, is what it is, right? The sector would be the whole
What is
thing.
that?
Okay? But we do know some stuff, right?
You know, the angle and a radius,
We have
right?
angle and a radius, right? Yeah. So maybe let's start with that,
Don't we
right?
use a formula? Don't we use a formula?
Yeah, what formula? What formula are we going to use? The area of the pizza
Depends.
crust.
Is-
I like the crust. Do you not like... Does anyone here not eat the pizza crust? I love the pizza crust. It's my favorite part. Just because it's all bread.
Is it hold on. Isn't it, I think it's something like pi over 360 times
Mhm.
wait, sorry, I meant theta. I meant
Theta.
theta over 360
8 over 360. Yeah.
times pi times whatever the radius is, right?
Pi r squared is what it is.
Or yeah, that's what it is, yeah.
Yeah, and the reason why
Right.
this is so this is, for instance, the percentage of the entire area is what it is. That's theta over 360. If it's given in degrees. If it was given in radians, you would have to say theta over 2 pi times pi r squared. This is for like radians. And this is angles. Yeah, so in
I'm just doing it in degrees.
yeah, do you see how... Yeah, this is in degrees, but do you see how this is like a percentage, right? Because there's 360 total degrees in the triangle. Sorry, the circle.
Alright.
So you're taking the amount out of 360 you have, and then you're multiplying it by pi r squared. And then that'll give you the percentage of the pizza you get to eat. Yeah.
Yeah,
Crust is based.
I just
Crust is
realized
based.
that in section B is they're asking you to find the shaded region.
They want the perimeter. So
Yeah.
we're eventually going to have to do this and this. This is arc length is what we're going to do. And I forget what this is, but we'll figure it out.
And you know that arc length is like my strength. I know the formula
cool.
for arc length.
Good. I'm glad you like it. Yeah, good. Nice. Okay.
Seriously, I already know the formula. I could tell you right now if you want.
Let's wait for when we get there. Okay,
Alright.
so area of the sector is going to be 74 over 360 times pi, and then the radius is 8, right? So that's times 64. Okay, ugly number. Whatever. Okay. So we got the area of the whole thing, right? So in order to get the area of just this, right, we probably need to find the area of this, right? Because if I take the area of this whole thing and then I subtract the area of just the triangle, then I'll get what's left. Okay, question is, how do I
Wait,
find the
hold
area
up.
of this triangle? Oh, this is a good one, actually. I like this. This is a good one.
Hold on,
What's
don't we
up?
already know don't we already know everything? We can already find the area of a sector.
You already found the area of the sector. The sector is the whole thing, Ethan. Now I need the area of this triangle so that I can figure out what this area is.
Oh wait, don't you just do like 74 over 360 times pi times 8 squared? Isn't it just that?
That's the area of the whole thing, Ethan. That's the area of this. That's the area of the whole sector, okay? We want the area of this region right here, which is like the subsector, okay? It's like the crust on the pizza. Yeah.
Okay.
8 sine of 74. Interesting idea. That works if we have right triangles, which we don't yet. But there is something cool about this. So we know that this length is 8. What do we know this length is?
8. I know
8.
that. There's no
Right.
question to that.
Because these are all radii, is what they are. Okay, so this is also 8, which makes this an isosceles
Radii?
triangle. Yeah, radii. It's a plural for radiuses. Radii. It's like Prius, prii. Okay.
You know, it's kind of reminding me of Colossus and Colossi.
Yes.
Instead of
another thing.
Colossuses.
Yeah. And then look what happens here. Okay, so now I have an isosceles triangle, which if I memorize the formula for the area of an isosceles triangle, I'm sure I could get it. Oh, thanks for the follow, man. The other way to do this is to just draw right here, which is what's this called? Angle bisector is what this is, which in an isosceles triangle makes a 90 degrees angle,
Isn't
90
this
degree angle here.
altitude?
It's an altitude too. Yeah, it's all the things. I think it's an altitude, it's a median, and it's an angle bisector because it's an isosceles.
Alright.
Yeah.
Well, yeah, I can see that. So I can see like we could use Pythagoras' theorem here, huh?
Well, not Pythagoras. Okay, because we know this is 37 degrees, right? We know I don't really know what this distance is, but I would like to know it, right? And then I would also like to know this distance, because then I would do 1/2 the base times the height, right? There may be an easier way to do this. Yeah, you're welcome, dude. I'm trying to think if there's an easier way to do this. If I like split it, there's some other probably circle theorem thing that works here, but whatever. So let's try to figure out what the height of this triangle would be, right? What would we use there?
Yeah. Wait. So Pythagoras' theorem won't work then?
No, because Pythagoras theorem only works if I have at least 2 of the sides. I only got 1. I could do law of cosines here if I wanted. I could do law of sines. Yes,
The cosines rule.
or I can literally just use the definition of sine. All right. So for instance, the sine of 37 degrees. Well, here, let's do this one. Let's do the height. Sorry. So I want the cosine of 37. So cosine of 37 degrees in this triangle, right, is the adjacent, which is the height, over the hypotenuse, which is 8. Okay. So that tells me the height is equal to 8 cosine of 37 degrees. Okay. That's this. And then to get this, the base, right? I know I can get half the base by doing the opposite one, the sine of 37. So I'm going to say that, so 1/2 of the base is equal to 8 sine of 37 degrees. Okay? That gets me this, right? Sine is opposite over hypotenuse. Okay? So if I want the whole base, I just multiply this all by 2. So base is equal to 16 sine of 37 degrees. Oh, thanks for the follow, man. Man, we might hit our follower goal this month. That'd be cool. Okay.
Nice.
Okay. Last thing to do is, right, to find the area of the triangle is to do 1/2 the base, which is
How's the radius? Or
the base 16 sine of 37 degrees times the height, which is
isn't
8.
it just radius squared?
No, it's not radius squared. Just
Wait.
Well, there
Okay.
will be a
Really,
yes.
I'm losing-
There will be an r squared from this technically. Yeah, 8 cosine of 37 degrees. Yeah. Okay, so this is the area of the triangle. What do we get from Gold when he hits 1,000? Do we all get a PS5? Yeah, let me talk to Sony, dude.
Now we don't.
Yes. Okay. Area of the area of the triangle. Okay, cool. So then if I want the area of the subsector, right, I'm going to do this minus this. Okay. Unfortunately, none of this is, I don't think any of this is nice because like we got sine times cosine, which that may be an identity, right? Isn't sine cosine like cosine 2 theta or something?
Cosine 2 theta, what?
There's some trig identity with double angles and like sine and cosine. I remember.
Hey, Dr. Go, you know what I realized today?
What's up? What'd you realize?
There's some specific. You remember how do you say it? It's like saying you know how the sine of 90 degrees is one. That is literally just the number one, right?
Mm-hmm.
I found out the cosine of 0 degrees is 1.
Nice. Yeah, that's a unit circle. That's
I
good
don't
stuff
even
to
know.
know.
How does that make sense? The cosine of nothing is equal to 1.
I'll show you. I can show you later. It's because it's the adjacent of a
And,
0
and
degrees.
also, I found out the tangent. And I also found out that the
Tangent of 0
like
is
45
0, right? And tangent of
No,
45
no,
is
well,
1.
I didn't. Yeah, that's the thing I forgot on. Not tangent of 0 is 0.
That's
But that makes a lot more sense than.
does it? Okay, there you go. There's the area
It
of
makes
this.
a lot more sense.
All right, one sec. And then we got 74 divided by 360 times 64 times pi. Cool. So the area of the sector is 41.33 So now if we do this- minus this. Yeah, this was a little bit trickier. There we go. So then we do this minus this, and we get wait, 36.7. What the hell did I do here, dude? What? Sorry. This minus, sorry, this way up here. I got the wrong number. Oh, it's 30.76. Sorry. I'm dyslexic today. 30.76. There we go. There we go. That gets me 10.57. Nice. Cool. Awesome. Sweet. What is luck? Sounds like Kingdom of Hearts. A unit circle basically goes off the X and Y axis. Yes. Yeah, exactly correct. And yeah, if, you know, so Ethan, you should always, like, I have these. If you want to know why, for instance, sine and cosine of 0, what is this? Refresh. What's this fucking up on? I have a video on that, why that is. Why does this not want to load today? There we go. Okay. Here, this is sine and cosine and tangent at 0 and 90 degrees. So this is like a fun little tutorial video I made on teaching the unit circle on how things work. So there you go, Ethan. Like, if you ever want to know why sine and cosine and tangent are all 0 and 1, here's like an easy visual way to see it.
All right.
Yeah. Okay.
At least, well, Dr. Go, that wasn't really what I was looking for. And that's not. I don't think that will come on my quiz. It's like
I mean,
has
you
to
should
deal
know
with,
the
like-
you should know the unit circle. Like that's always a necessary thing.
the unit circle. Well, we might.
I
learn
never
that
memorized
later.
it. Yeah. So PUBG, you don't need to memorize the unit circle. Like, in order to do the unit circle, you only have to know 2 triangles. It's the 45, 45, 90 and the 30, 60, 90. And once you know those 2, you can figure out any of the special angles on the unit circle. Because I know, like, memorizing this whole thing, like, sucks.
Memorizing what?
This, dude. Dude, some teachers make them memorize this, dude. Like, don't. This sucks.
This-
Like,
This is not right.
yeah.
What?
You-
11 pi of 6. What?
Yeah, well, this is radians and degrees, but you don't need to memorize this. And I show this in, I think it's these series of videos I have here. I think there's just 2 of them. Yeah. Oh wait, this one. So you need this one, this one, this one, and this one. But these ones basically show you that in order to do any of the angles in a unit circle, all you have to do is just look at what the triangle is. Wait, what is this? Does this not skip forward? Anyways.
All
Go
right.
ahead, started super nice. Yeah.
Well, could you?
Yeah, because this
Dr.
sucks.
Go,
Like, no one
could
wants to
you
do
at
this.
least Dr. Go.
Yeah, see, because look here. All you have to know are these 2 triangles. Well, one second, I'm responding to PUBG. And if you
Sorry.
memorize the sides of these triangles, all of the trig identities, which is like opposite of our hypotenuse, adjacent of our hypotenuse, opposite of our adjacent, is just like making these triangles on whatever the angle is, and then doing the ratios of them. So so yeah, watch. I show you how you do it. You basically draw the angle and you identify, oh, which triangle is this? In this case, it's the 45, 45, 90. You write out what the sides are for a 45, 45, 90, and then you can do all of them. You can do all the adjacents, all the opposites. You can do whatever you want. Yeah. And this works in all the quadrants because then whether the adjacent or the opposite or positive or negative just depends where you are. Yeah. What's up, Zach? Happy Monday. Math Monday.
Also, Dr. Go,
Now I just feel like I'm a dummy. Yeah. What's up? What's up, Ethan? One sec. Let me pull this one in for him as well. There you go, PUBG. That's how you do that one.
So yeah. The thing is that what I heard from my quiz is that I will be getting like maybe the area of an arc length, not
Yeah.
area, no, like the formula for arc length.
Well,
area
that's
of
what this
sector,
one
area
is.
of-
That's what this one is right here. So this second question here, equity, is we're trying to find the perimeter of the shaded region, which is this, okay? Which means I need the length of this, which I already got, right? I already figured out what the base was when we did this, right? When we figured out this triangle and we figured out the base and the height, I already got this length. So that's 16 sine of 37, which is nice. Okay, cool. 16 sine 37 degrees. What the next part is, which you probably know, Ethan, how to do, is this, which is the arc length. Do you know how to calculate arc length?
Yeah, like I said, I remember the formula.
Okay, what's the formula? I'll show you why the formula makes sense. It's actually kind of intuitive.
So if I can remember it correctly without looking at a notebook,
Uh-huh.
then
what
it
is
should be pi over. Sorry, not pi. What? Keep confusing that. Theta over 360
Yes.
times 2 times pi times r.
Yes, cool.
Nice.
Again, the reason
Yeah,
why
that
this
was- yeah.
is, do you know why this is, Ethan? Like intuitively. It's cool to memorize equations and everything, but it makes more sense if you know
Sense
why
on-
this is. Or it'll stick better.
Why then?
Okay, what is 2 pi r? Do you know what 2 pi r is in a circle?
Well, then I don't know. Well, hold on. What is 2 pi anyways? Like 6.28 or something?
No, don't worry about the number. Like, do you know for a circle what the equation 2 pi r describes? Yes, good job, Pub.
No, I don't
This-
get it.
This
I
is
don't
the
get it.
circumference. This is circumference.
Circumference of a circle?
Yes, so that's the total perimeter of a circle, okay? And then this, remember, this is the percentage of the circle, right?
What?
Right? This is like the percentage of the
Oh.
circle because there's 360 degrees going around the whole circle. So theta over
Yeah.
360 is like the percentage of the circle you're going around.
All right.
And then so whatever that percentage of the circle is times the circumference, that's the arc length. That's like the percentage of the circumference. It's the arc.
All right. But you want to know what I learned today about maths?
What'd you learn? Dude?
Well, honestly, I kind of got a question that's very similar to this, except for the fact that I had to use like involvement of the cosine rule and area of a segment. I don't know what the topic is called, but
Mm-hmm.
really,
Well, I mean, that's
it's
kind of what we
it's-
just did right here. That's exactly what we did right here.
Well, where did you put the cosine ruler? Like you didn't wait. Did
Oh,
you,
I
did you
no, we
implement that?
didn't do law of cosines. I could have done law of cosines, but there's no need to.
You'll do that better. I'm more used to this right now.
Okay, good, okay. All right, this is 10.33. Okay, so equity. The total perimeter is going to be whatever this is. Wait, sorry, I already calculated. This is 10.33 plus this. So plus 16. What is this? Sine of 37. So there, your final answer is 19.96. Okay. So this is 19.96, and then this one was 10.57. All right,
All
equity.
right,
Let
well-
me download that one for him real quick.
So Dr. Go, I've been
What's up, dog?
getting a pretty good start on my second semester.
Okay, good, dude.
I have
Uh,
gotten A's in most stuff.
Wait, Equity says, why isn't the arc length 74? Okay. So the arc length, Equity, is it's 74 over 360 because that's the percentage of the triangle you're looking at, 74 degrees out of the 360 degrees. And then you have to multiply it by the total circumference, which is 2 pi r, Equity. So that's why it's 74 over 360 times 2 pi r, which is 2 pi times 8. Yeah, 74 is the central angle. I agree with that. That's what I think what they're calling this, the angle of the sector. But to get this length, right, it's 2 pi r times the angle. And actually, let me think. How does this... I think if you convert this into radians, I think... isn't it like r... Oh, I know what you're talking about. Doesn't the central angle equal the arc length? Okay, no. So r theta does equal the arc length, I believe. But that's if this is in radians. Okay? This was in degrees. And so the conversion is what is it? Theta over 360 times 2 pi r times 2 pi. That equals, this is in radians. This is in degrees. Yeah, so, and you'll see that becomes the same equation then, right? So if I were to plug this into here, that gets me my 2 pi r over 360, which is this. This is when it's in degrees. Yeah. So Equity, if you want like a quick little thing, right? So arc length. So when theta in degrees, that's theta over 360 times 2 pi r. And then when theta is in radians, that's theta times r. Yeah. Percentage of circle. Yeah, I feel like the percentage of circle makes more of an explanation. Makes more sense to people. Yeah. All right, cool. Does that make sense, Equity? Yeah, and this is, again, why I don't want you to just, like, memorize equations, because they don't apply all the time. You know, sometimes things will change. Like, they'll give it to you in degrees, they'll give it to radians. And if you don't understand, like, where the equation comes from and you're just memorizing stuff, like, you're going to get it wrong. Yeah, you're very welcome, dude. Nice. Okay, cool. All right, let me give you coins for that.
What can we do, like, an example for me?
Let me see. Let me get through everyone's real quick. Oh wait, did I only give 1,000 to
Yeah, you did.
no.
You did.
Sorry. I should have given it. Sorry, let me give another 1,000. To Not Your Friend. Cool. My bad. There you go. Sorry. Forgot it's 2,000. Yeah, there you go. Okay, and then you get the weekly question roll. Damn, bro's rich. Bro's hella rich. Okay, let's see. What do we got next? Half Alpha is next. Again, yeah, if you're just finding us from Twitch and whatnot, the best way to get your question up on the stream and have me go over it is to join our Discord. There's our Discord. And then there is a channel called Help Screenshots. So if we go here, and in this channel here on right here, help Screenshots. All you can do is post screenshots. It won't let you post any text. You have to only post screenshots. And I will try to go through these in order of people that submit. I'll give some slight preference. If you've never asked a question before, I can skip ahead and do yours, but we'll be here for a bit. Okay. Half Alpha. Okay. Get Half Alpha's up. Okay. Cool. What's up, Half Alpha? Are you here? Bum.
Nice.
Mr. Bean's gonna chill around. Oh, thanks for the follow, man.
Well, I'll be gone for a while, but I will be back in time for my question. Will it be very last?
Maybe. I don't know. Let me see how many people I gotta go through.
Okay.
If not, if I don't get to it, I'll just count that other question as yours as well. It's okay. Follow me back. Well, I can't follow you back right now because I'm streaming right now, dog. What? Tell me to do stuff while I'm streaming. Excuse me. Okay, here. Bop the bop. Bop the bop. Okay. Solve for all values of x. Ooh, we already tried one attempt. Oopsies. Okay. Let's try to do this. Oh, very cool. First thing I want to do is probably combine denominators, right? I don't like having all these fractions. These look ugly, dude. So yeah, let's try to combine some denominators. First thing I'm going to do is, this is a trick here. This is a trick I'm going to teach you guys. Okay. Anytime you have a minus b, this is the same thing as -1 times b minus a. So if you ever want to switch the order of these things, just multiply everything by -1, okay? So instead of 2x over 9 minus x, I can rewrite that as -1 times 2x over x minus 9. This is a good trick to know. 30-year-old gold and dom shot, dude, I'm down. Yo, what's up, Noise? Yeah. Noise already got it, dude. Yeah, okay. And so because this is a -1, that's going to flip this to a positive, okay? So let's move this around. So I got x plus 3 over x minus 9 plus 2x over x minus 9 is equal to, this is a plus, is equal to 2x over x minus 9. Oh, that's nice. Wait, so this shit just goes away? Oh, I don't even have to do anything here. This is actually kind of nice. Yeah, so here, let's just subtract x minus 9 on both sides, right? So these are going to go away. And I just get x plus 3 over x minus 9 is equal to 0, or x plus 9 is equal to 0. Okay. Which just means x is equal to -3, I think, right? Can x equal 9? I don't think so, Noise. Could it? I don't think 9 would work. Or maybe I got rid of that solution by doing this. Hello, gamers. Yeah, conjugate. Yeah, exactly. Yeah, conjugate is like a plus b versus a minus b. These are conjugates of each other, which is good for the, what is it? The sum of squares or difference of squares. But yeah, this is a trick. I just see this a lot. You know, you'll see like 9 minus x and you're like, ew, this is ugly. And so the way to rewrite that is -1 times x minus 9. It's just it's a cool math hack. It's a good math strat to use. Yeah, okay, so this one's just -3. Nice. Done. Half alpha was it 2000? And then I'll give you the roll. Okay, cool. Let me download this for you. Math hacks with Dr. Goldie. He's here all week, folks. Yeah. It's actually pretty cool. Did anyone else have anything fun happen this weekend? I went to a Grammys party this weekend, thanks to Bonmy Boy. Bonmy Boy 1 helped me out with there. They threw this party for his company VinFast, which he was on the AMA on Friday talking about his work there. They're an electric car company. They spent apparently $500,000 on this party. It was a massive mansion. They had caviar, lobster rolls. Like I got pictures of it. It was actually pretty funny. Let me see. Do I have any photos of it? Yeah, one sec. This was it. Yeah. So I had these lobster rolls with caviar on them. I'd like never eaten that before. I was like, what, lobster caviar rolls? And then what was very cool is I ran actually into some other streamers, I guess, that maybe you guys know. I got a picture of her somewhere. Where is it? Come on, girl, you want to load? Load today. There we go. Maybe you guys know this one. Her name is, I think, Tina Kitten or something. Let's see, Twitch, Tina Kitten. Yeah, there we go. Yeah, this girl. Wow, 1.9 million. All right. She's got quite a few more followers than I do on Twitch. But she was really nice. And then we ended up getting dinner randomly afterwards. And then who else did I run into? Oh, this girl that reviews parking lots. What is her name? Yeah, this chick, whatever her name was. This girl right here, which I think her name was like Misa something. What was it? TikTok. Misa something. I don't know. Misa, like, what profile is this? There you go. This is her. Yeah. But yeah, 950 on TikTok. She reviews parking lots, which I think is pretty funny. Hey, parking lot review is basically a dream job. Yeah. So she just reviews parking lots, apparently. She told me, she's like, I review parking lots. It's like, okay.
To start, the lines are a little bit faded, but
Oh my god. Anyways. It was a fun weekend. I had a good time. She's very pretty. What an epic hobby. Yeah, I know, right? Is she a yoga streamer, deodorant streamer? Okay, cool. All right, let's see. Yeah, it's an epic hobby. I think, but you can honestly only get away with that hobby if you are pretty. Like, I say if I started a TikTok for rating parking lots, I don't think I'd get any followers or any views. I don't think it would happen. Yeah. Okay, let's see. Teacup. Oh, Slope Fields? What? Teacup? Teacup, come up here, dude. What's going on? What am I doing here? I'd follow you. I appreciate that noise. Thank you.
Nice.
Appreciate that noise. Yeah, I'd follow you too. I have a call with the guy from Unlock Learning. I think I showed this guy to you at some point. Was it one Unlock Learning Instagram? This guy is very cool. I really like the way he teaches. Is this him? No, where is one sec? Unlock. Yeah, this guy. So he does he does a bunch of, I think, like AI voice stuff.
Yo, what's that?
It's literally just another function.
He has like
Big
celebrity AI voices explain math concepts, which
is the area under the curve.
yeah, this guy, yeah. So I reached out to him because he has some really cool videos. I like the way he teaches. Like, besides the funny trick of using celebrity AI and stuff, the way he explains things, I actually resonate a lot with, because he has a very good intuitive way of showing things. So I got a call with it. He's actually based in the UK though, so we were like trying to work out time zones. But these ones are hilarious. Yeah, I'm gonna talk to him tomorrow about maybe collaborating on some stuff, because we both make like tutorial videos. He's got a cool style. I like it. Oh. Based in the UK. Yes. He's double based. Teacup, what's up? Are we doing your question, or am I doing Jamarcus's? Okay, I guess I'm doing Jamarcus's. Jamarcus, you're here. I know you're here, Jamarcus. What's up? Jamarcus says, I don't have a picture, but if it's possible, could you go over some stuff about quantum operators and state vectors? If not, then just some vector stuff in general would be fine. Oh, interesting. Yeah, how much of quantum physics do I remember? Quantum was actually one of my hardest classes in grad school. I absolutely hated it. But remember when I thought when Jamarcus was back? Okay, Half Alpha, you're good. Half Alpha, I answered yours earlier. I think I sent it to you. Did I not? Yeah, it's right there, Half Alpha. Here. We did it. It's okay, Half Alpha. I did yours. Yeah, Jamarcus isn't. Yeah, what's up? Okay. Operators and state vectors. Yeah, so it's interesting. A lot of quantum physics goes into calculus with what are called like integrals and things, which again, I don't know how much of integration you've done yet, but a lot of times what we have, let me just get some pictures of this stuff. I could draw this, but it would take forever. Let's say quantum wave functions. Okay. So, wave functions. This is where everything eventually comes from. Here, I need a better picture of this. Ugh, you're gonna make me go through this video? All right, whatever. Hey, YouTube's always your friend. There's tons of this, but what it comes down to is there's an equation called the Schrodinger equation. Okay, so here, Schrodinger wave equation. Okay, which is this. Here, hyperphysics is great. Actually, I do like hyperphysics. Hyperphysics got me through a lot of my physics. Yeah. Okay. Is that the equation that deals with cats? You know. But yeah, this is where it comes from. So here's the equation, which is it comes from it's cool. It comes from the physics concept of conservation of energy, where we have that the kinetic energy plus the potential energy of something must always be the same. So in physics, classical physics, which is not dealing with quantum stuff, kinetic energy is 1/2 mv squared, and then potential energy, right, of a spring is 1/2 kx squared, and this all equals some constant energy. In the quantum state, when we start getting down to things that are very, very small and moving very, very fast, now what we have is energy through another kind of cool calculus trick, which is called Hamiltonians and Lagrangians. And there's Noether's theorem and all these things. But this is where all the calculus you learn in college starts to build into doing higher level physics things. But it's kind of the same concept. Kinetic energy here is instead written as momentum, which is p squared over 2m. And then they still put this 1/2 kx squared, but then they show what the Hamiltonian form of it is. And you end up getting this equation, which there's a better version of this. What is it? Schrodinger equation. Where's just the equation for it? Yeah, there you go. This is what I want to see. Yeah, there you go. This is the famous Schrodinger equation that you use in quantum physics, which has to do with here's like a description of all of it. So mass, wave function here. I'll explain what the wave function is. Wave function describes like where a particle is. So in quantum physics, a lot of times what we deal with is called the particle in a box. This is the classic question that always gets asked in quantum. And what you think about is you have what's called an infinite potential well, which you can think of as like a massive well, and a particle bounces back and forth between these two walls. And based on that, it can have a bunch of different what are called energy levels. So basically, however much energy it has, it will have a different like path that it travels between these two walls. Which this is this. And then, yeah, the whole reason this is called quantum physics is because energy is quantized. Quantized means it's not continuous. It means that there are individual like levels. So the same thing gets seen actually pretty cool. All of this connects. Because if you go into, for instance, like chemistry, electron shells, electron levels, yeah, this is kind of all the. I really want to see is what is it? I think it's called. It's like the Balmer series. Yeah, this is what we talk about. Okay, yeah, everything like relates back to the hydrogen atom at some point, but you will eventually learn in. There you go. Let me open this one. In chemistry, you learn about how electrons can occupy different levels or different like orbits within an atom, such as like n equals 1, n equals 2, n equals 3, n equals 4. And because these electrons are in just certain areas, like they don't really lie in between probabilistically, that same quantum or quantized energy level is the same thing that happens with the wave equation and doing this. So in quantum physics, a lot of what you do is you solve for the hydrogen atom doing this, using this particle in a box, defining energy, and then, yeah, it's just a lot of this stuff. But it's cool. Well, Teacup, I called you for your question, but you weren't here. You have to be here for me to get to your question. Yeah. Anyways, you've taken 5 notes on vectors and stuff. Yeah, here, let me see. Let me see. Is this, so what are you doing? Yes, okay, cool. So yeah, so Jamarcus, what you're starting to do here, do you see this phi here, this funny symbol here? That's the same thing that's in here. It's called a wave function. And a wave function basically just describes where a particle would be or most likely to be, based on its energy and based on how wide the well is what it is. So, yeah, you're going to start doing these things with operators. Oh, man, and yeah, okay, yeah. It's cool. Yeah, they call this Bra-Ket notation, is what it's called. Bra-Ket. I love cat, but you don't understand that much. It's okay. This is something that you eventually will just accumulate after enough time and whatnot. Yeah. Yeah, if again, and it's all connected. So if you want like a good like intro, this is a great thing for the Schrödinger equation. Just in general, hyperphysics is actually quite great because, for instance, here is basically all of quantum, and you can start going down the paths of what you do. So, for instance, quantum physics describes nature with wave functions, which uses the Schrödinger equation, which you can then find out hydrogen energy levels. So, remember when I was saying chemistry, right? Chemistry, like this stuff. It's the same thing in quantum physics. We deal with energy levels like this. It's all very cool. And then yeah, here's the spectrum. Right. This is the radiation you calculate in, I forget what that equation is called. He knows a lot of stuff. Yeah. Okay, cool. Haha, bra. Yeah, I know. Bra-Ket. Yeah. Yeah, it's funny. Anyways, cool. I hope that's kind of a good intro into what quantum physics is. If you have any like specific questions that they give you for your class, like put them up here. I'd love to try to do them because it's been a while since I've done quantum physics, but I always enjoy a challenge. Yeah, good. Nice. Okay, cool. All right. All right, next we got QVNTT. Oh, this is cool. Looks like we're doing some chemistry. I do everything these days. Chemistry is actually one of my... Like, if I had to rank, like, what the things I like, I think it goes like... It's like physics and calculus are kind of tied, and then it's chemistry, and then it's statistics. I enjoy teaching those. Those are, like, my favorite ones to teach. Okay. What's up, QVNT? What's up? So this looks like chemistry. What is an intermolecular force and how does it differ from a chemical bond? Okay, that's cool. So intermolecular forces describe forces between molecules, whereas I think with chemical bonds, that's more of the bonds in between elements of a molecule. So, for instance, this is the classic one we see. If we have what is it, H2O, right, which looks like this. Okay. I can do 6th grade science. Well, this isn't 6th grade science. This is probably like, this is high school chemistry, I think. Right? We did your, well, Teacup, I asked, you're old. Yeah. Okay. Yeah. What's up? Honors chem? Yeah. Okay, great. Okay. So, for instance, this is a molecule, okay, of water. Great. Okay. Yeah, good, Teacup. I'm glad. Okay. We'll get to it. Now, within this molecule, right, you have bonds, chemical bonds between the oxygen and the hydrogen, right? This is just a regular bond. The other classic one they see is it like CO2? What's the structure for CO2? Sorry, I gotta figure it out. Yeah, double bond. Okay, cool. Got it. All right. So this is another classic one they like to do, right? C double bonded to O. Two very important things that you probably see in your life every day, right? Water, this is what you drink, and then this is CO2, which is a gas. This is what when you breathe out, when you exhale, this is CO2. Now, within this, this is a double bond, this is a single bond. These are what I would say are like chemical bonds, right? Intermolecular forces deal with the forces between the molecules. I think these chemical bonds, I think in this case, they're talking about what are called like intramolecular forces, which can be either ionic, covalent, or I think metallic is technically another bond they talk about, right? Yeah. So, ionic bonds, right, is whenever you have something from the periodic table from here, bonding with something from here. And then covalent bonds is whenever you have something from here bonding with here as well. So intermolecular forces are the forces in between different molecules. So for instance, if I had, one second, let's say I had 2 water molecules, all right? No. There we go. Okay. If I had 2 water molecules next to each other, what probably would happen is there would be a bond between the hydrogen here and the oxygen here, okay? This is an intermolecular force. Oh, you just need 2? Okay. Well, here, this is a good thing to, like, show. So, and this is an example of, like, a hydrogen bond. NaCl is covalent? No, NaCl is ionic. Because sodium is way over here, and chlorine's way over here. That's an ionic bond. Yeah, it's okay. Okay. Yes. Okay. In specifically, this is a hydrogen bond because you have hydrogen bonding with either nitrogen, oxygen, or fluorine. That's what hydrogen bonds are. Okay. So, here we go. They say forces and the state of matter. I don't know how you can just intuitively see what the state of matter is. I think you'd have to, like, look that up. Like, I know this is a liquid, right? Gold? Gold, that's my favorite. This one's a solid for sure.
Nice.
Yeah, you can look these up. I think silicon dioxide, man, what is that? That is probably a solid. Yeah, silica. Oh, yeah, exactly. It's quartz. Oh, cool. I didn't know that. Yeah, it's quartz. Here, let me close all these out. Okay. Okay, but to figure out the type of force, I think there are basically 3 that you learn, right? You learn about London dispersion, dipole, and then I think hydrogen bonds are the 3 main ones. You tell me if those are the ones, because technically there are more. There's a whole, I think there's like 5 of them technically. Okay, no. They just do London, dipole, and that. Okay, good. Yeah, I've seen some other charts where they describe like induced. Okay, this is it. Yeah. Which I don't think your teacher's gonna make you go this extreme. You learn like 6 or 7. Oh, okay. Well, yeah, because there are these technically. Yeah, but I mean, the main one you deal with is it a hydrogen bond? Is it dipole, or is it dispersion? These are really the 3 you use. Oh, okay, let's see. These are the ones you have? Let's see. What do you got? Macrocovalent, macroionic? What? Stop. Metallic. Okay. All right. Yeah. Okay, fine. Okay, yeah. So again, these are the... usually in a chemistry class, this is what they ask. They just really just ask for these ones, okay? Is the molecule silicon with... I've never seen this. Macrocovalent? Is the molecule silicon with oxygen or just carbon? Wow, okay, cool. I guess this is a... Chemistry always has exceptions, unfortunately. It means it kind of sucks at times. Yeah. So, yes. And then ionic is whenever it's something with the left side with something with the right side. And okay, only metal is metallic. Okay, so, I mean, going up here, right? Which ones are only metal? That's definitely this, right? So this is metallic. Gold is a metal. MgCl2. That has to deal with... Do you know QVNTT, how to figure out whether something's ionic or covalent? It seems like Noyce needs a little refresher. Yeah. Okay, cool. Ugh, pasting so many things in today. Yeah, okay. So because MgCl2, right, is this, bonding with this, that's an ionic compound. When they go across the pond, like when me and Noise talk to each other, that is called ionic. So this one is, and then what? You guys say that if it's just ionic, then it's macroionic. Cool. That's okay. Okay. So this one's macro ionic. This is the macro covalent one, which I guess is a special case just for silica. This is a metal with a non-metal. Only contain metal. Is that ionic though? AlCl3? One sec. AlCl3 is covalent. Okay, cool. So this is probably then London dispersion is what this is. No, it's okay. And then this is hydrogen. And then this is going to be oh, okay, so the other thing you got to check is whether it's polar. Do you guys have that? Yeah. Do you know how to determine whether something's polar or not? .4 to 1.7. Yes. So that's okay. That's interesting. That's only between individual elements. Yes, you're right. Whether the bond is, that's if it's one thing with one thing. So for instance, one second, I need a table now of the what is it? The polarities. All these tables, dude. Or it's electronegativity is what it is. Yeah, here we go. Can I get something that looks nice? Here we go. Cool. Okay. So, for instance, yeah. So, if I have, let's say, just N bonded with F, like NF, okay? Then, yes, you look at the electronegativity difference here, right? Which is 3 and 4. So, that difference is 1. And since 1 is within the range of 0.4 to 1.7, yeah, we call that being a polar bond. However, things get a little trickier if we start putting a bunch of different things on it. Okay, so let's look at, for instance, like CH4, right? Or CH3. CH3 is a good one. So you may be tempted to say like, oh look, carbon and hydrogen, that only has a difference of 2.5 to 2.1. So that's basically nonpolar. That's basically nonpolar, right? Which, correct, the bond between the individual carbon and the hydrogen is nonpolar, but what you have to do is look at what the shape is. So this requires drawing what's called a Lewis structure, okay? Which, here, I'm just gonna get it just for the point of saving time. I'll show you just where you would get it. And then I need one other thing, which is on geometry chart. Yeah, these charts. These charts are great. I love these charts. Where's the one that has... Yeah, this is what I want. I like this one. Okay. So, yes. So, while the individual polarity between carbon and hydrogen, or the electronegativity difference is low, which means that it's technically a non-polar bond. The problem is you have to look at the overall shape of what this thing is. So when I draw CH3 minus here, I guess, sorry, CH3 minus, this is carbon bonded to 3 hydrogens and then a lone pair electron, which if you look here on the chart of what that shape is, all right, so one lone pair with 3 things bonded to it. Well, this chart sucks, actually. What? No, I don't like how they do this one. Sorry, this one really sucks. Where's my just basic-ass chart, dude? What? Yeah, let's just go with this. Not this one. This one. There we go. Let's go with this one. Sorry. I don't like how this chart is organized. There we go. Okay. So, you have to look at what's called like the steric number, which is the electron geometry. And that's how many bonds does this thing have and how many plus lone pairs. So this has 1, 2, 3, 4. So that means we come down to this row. And then it has one lone pair, which is here. So that makes it what's called trigonal pyramidal. And a trigonal pyramid, which ends up looking like this. So you have C bonded to H, bonded to H, bonded to H, but then there's a lone pair up here. Overall, because this structure is not symmetric, this is going to end up being polar, is what it is. Because this lone pair here screws things up. The only ones that are non-polar here is going to be this one, this one, this one, and this one. Oh, I think this one as well. Yeah, and this one? I think this one as well. Okay. Yeah. Bro, my teacher's chart was better. Yeah, it was. Dude, your teacher's chart was so messed up. Yes, I do everything. Yeah, okay. Okay. So, yeah, you have to know, like, in terms of the whole structure, QVNTT, whether it's polar or non-polar. In general, if there's ever, like, we did Lewis stuff last unit until I already forgot it. Yeah, this is why you can't forget things in chemistry, especially chemistry. Chemistry all builds upon itself. So you learn how to do Lewis structures, and then once you learn Lewis structures, you learn how to do the geometries here and whatnot. And then these are required in order to determine, the intermolecular forces, whether it's polar or stuff. So in the case of NF3 Lewis, yeah, NF3 looks like this, which is cool. So NF3 is actually very similar to the one we just did, very similar to CH3. NF3 has 3 bonds and 1 lone pair, which makes it polar. Okay, so because it's polar, this is going to have dipole bonds as well. Okay, and then I think all of these have dispersion. I think everything by default can have a dispersion force in between itself, London dispersion, but then these are like the special ones. London's dispersion just means that two things get next to each other and they polarize each other. Yeah. Anyways, does that make more sense, QVNTT? I know there's a lot of concepts here, but hopefully it's kind of like a brief overview. Okay, cool. Awesome, good, nice. All right. Is it your turn? Yeah. Oh yeah, you are up next, Jerbeefus. Nice. One sec. Let me give coins to everyone. JV. No. Oh. JV. Oh, QVNDT. That's it. That's it. Sorry. I got you. There you go. Good. Good. Okay, nice. All right, yes, Jarbeefus, you're up next. Nice. Okay, cool. Oh, yeah? Yeah. All right, one sec. All right, one sec.
I think I can find a question.
Let me go through the chat real quick. Let me see what everyone's been saying. Dun, dun, dun. We haven't gotten taught this. You have any advice for how to remember things? Flashcards? Or practice, honestly. Beans and beds. Yeah, if you really want to remember things, like doing things is the best way to remember it. So this is why you have homework. Although I know some teachers, for whatever reason, don't give you homework. I have some kids who are like, oh, we don't get homework. And I'm like, how do you learn? Or how do you remember anything? You have to do stuff. The only thing I can remember is numbers gold. What is this called? Do you know? What, remembering numbers? I don't know. But yeah, the best way to remember, and again, I understand why it's hard for you guys to remember things because whatever social media stuff you guys are exposed to all the time is just like swipe. It's just constantly like the next thing, the next thing, the next thing. So it's hard to probably focus and learn things for long term because you're so used to constantly seeing new things in the short term. But things like, back in my day, we had to actually have, these note cards, these to actually learn things like flip cards. Y'all have Quizlet, which is great. Quizlet is awesome. There's websites that there are Quizlets people have created on everything. So Nick says, I have a really hard time remembering things from birth. I have a bad memory, but numbers, it can be weeks and I would still remember. Zach says back in my day. Yeah, right. Back in my day. We didn't have Quizlet. Yeah, I'm old. But yes, yeah, I know. And again, it's not really your fault. The problem is how society works, advertising, clicks, dollars. They prioritize just quick bursts of what's the next thing, like click this, go to this. Engagement. But the world requires you to remember things for a little bit longer than a 15-second TikTok. So yeah, the best way to get better is to practice. So do some homework. Or I had to walk uphill both ways. Wait, how does that work? Did you have like an MC Escher path to school? You guys probably don't know what I'm talking about. MC Escher's dope. Yeah, this is where is it? The stairs. Yeah, dude, this one like trips me out, dude. Yeah. Was it Penn Center? Was this your walk to school? Did you have to do this? Yeah, MC Escher is dope, dude. He's a math artist. Was he a mathematician? I feel like he sounds like he's a mathematician. Oh wow, you're in April probably. Yeah. The other one is what is it? It's the impossible triangle. This is another classic one. Where they're cool optical illusions. You can't really understand them. This is another one. This guy right. Oh, this is Roger Penrose. Oh, I forgot this was Penrose. It's funny. My friend actually gave a speech to Roger Penrose. I need to get him here on the stream. He's a cool guy.
What about optical illusions?
Optical illusions are like things you look at that don't really they kind of like hurt your brain, I guess. Like this is the classic Penrose triangle. You look at this and your brain tries to like realize like where's a side or something. Did he? Oh, that was his science, really? MC Escher art. He did a lot of really cool art. Like this is another very cool one. This is impressive, being able to draw something in spherical coordinates. But yeah, this is another famous one of his. Where is it? Yeah, like the constantly walking uphill. Yeah. Oh, he was published. Okay, that's cool.
Yes.
I didn't know that. Yeah, he sounds like it. MC Escher. It's either that or he was a DJ.
That's dope.
Sickest MC on the lot. MC Escher up in the house. All right, cool. Let's get Jarbifus up here. Oh, this is cool. Oh, this kind of goes back to what you guys were talking about with what was it, Pythagorean stuff, right? What's up, Jarbifus? Yeah. It's law of cosines. It is. Yes. Okay. Yeah, exactly. Okay. So there are a bunch of different like triangle things we learned, right? So we just as a quick review, just for everyone else who hasn't seen this, right? We have Pythagorean, and then we have like the trig identities. So this is your classic a squared plus b squared equals c squared, and then this is your like sine is equal to like opposite over hypotenuse. These things are great, but they only work for right triangles. Right triangle, which I think that whatever, I'll just draw something like that. That's a right triangle. Okay, cool. All of these things are like for determining sides and angles of triangles. Our favorite thing. We love triangles. I'm actually learning to love triangles with all the triangle questions you guys give me. Okay, so these only work for right triangles, but then we can have something for all triangles, and that's what we call the law of sines, which says that sine A over A is equal to sine B over B. And then we have the law of cosines, which says that c squared is equal to a squared plus b squared minus 2ab cosine of c. Okay. So why these are useful? So this is useful if you have you need 3 out of the 4 is what you need. So here it's 2 sides and 2 angles. So if you at least have 3 out of the 4 things here, you want to use law of sines. Here it's 3 sides and 1 angle. Okay? So if you have 1 angle and 2 sides, you want to use this. If you have all 3 sides and you're just trying to find the angle, you want to use this. But for instance, like, 2 sides and 2 angles, does that work? Yeah, because you'd have 2 sides and 1 angle. You could also use law of cosines, but it's easier to use this. Yeah. So this one, is going to be law of cosines because we have 2 sides, an angle, and we're trying to find the third side. So this is always the combination of, like, have and not have. Okay. All right. Okay. Do you know how to do this one, Jarbeefus? Do you know how? You want to teach the class? Kind of? Okay. How do you think we do it? I can already tell this is going to be weird because this is an oblique angle, which I know is going to screw things up. Yeah, you have a bit of trouble. I remember the formula. Yeah, okay. So, yeah, it's c squared is equal to, right, a squared plus b squared minus 2ab cosine of c, okay? Where in the triangle, right, this side corresponds to this angle, okay? So since this is our angle, this is going to be our c, okay? So this is like c, and then this is big C, okay? Nick, I remember doing this with you one time. Remember you had these questions and we kept getting the wrong answers? Yeah. Okay, and then the other sides are A and B. It doesn't matter which one you call A or B, because you see here, right, we're either just going to add them or we're going to multiply them. So it doesn't matter which one is which. Yeah, Nick, we did do this. Yeah, we did this. Okay. So this is going to be equal to 20 squared plus 25 squared minus 2 times 25 times 20 times the cosine of 108. My memory is sexy as hell. Yeah. Okay. Oh, this is easy. You know what? Oh, thanks for the call, dude. You know what actually gets weird with this? What gets weird is if we're trying to find the angle and it's an oblique angle. Because I think if you do the math here, you'll end up getting the acute one. 686. Yeah, up we go, man. Okay. Yes, exactly. Good. Yeah, good. Yeah. X squared, you got it. Yeah, 400 plus 625 minus 1,000 cosine of 108. So this is nice. Here, I'm gonna do another one with you to show you what I'm talking about when things get weird. Because it has to do with when you're trying to figure out the angles. Okay. So 400 plus 625, right? Minus 1,000 cosine of 108. Great. Cool. And then we square root that. Yeah, and that's just going to be 36.52, right? So then, yeah, you got to do the square root. Did you remember the square root? Yeah, don't forget the square root. Yeah. Don't forget the square root. Yeah, good. So yeah, this one is going to be 36.25. Yeah, another way you can always check this to make sure this like makes sense. Is that the sum of any 2 sides of a triangle needs to always be bigger than the third side. Okay? So, for instance, if I take these two sides, right? 25 plus 20, that's equal to 45. Do you see how that's bigger than this one? And then, like, this plus this is 61, which is bigger than this one. This one plus this is bigger than this one. Yeah, okay. If you had not squared this, right, and you got, what was the number earlier? Yeah, what, 1,334? If this side was 1,334, notice how adding these two up isn't bigger than this side. So that tells you that that's impossible. You can't make a triangle that's 1,334 here and then just 25 and 20 here. Because this just adds up to 45, which is less than that. Yeah. Okay, let me show you another, let me get an example of I just want to pull it up for a second. Law of cosines question, oblique. Yes, this is finding the angle measure, which is tricky. Yeah, no. I want one where I don't have it. I think it's like if I have three sides. No, okay. Law of cosines question. I just don't want to design a question that's wrong. Okay, yeah, here we go. Oh, it does work? Oh, the negative does work. Okay, I thought it didn't for some reason. Yeah, three sides, no angle given. Yeah, that's what it is. Man, I wish you would remember, Dark, like what your question was when it was wrong. Because remember we kept getting that one wrong. Okay, whatever. We could try to do this. Yeah, you don't remember? Or maybe it was finding the... Yeah, okay, here. Let's try this. Here, let's do... Well, I need a triangle that works. I'm in the second grade. This will probably go hard in a couple of years. Yeah. Wow. Well, welcome to finding us, dude. All the way from China. Wow.
That's dope.
Okay. Yeah. Let's try to do this. Let's try to, for instance, let's try to figure out what this angle is. Right. Okay. So again, c squared equal to a squared plus b squared minus 2ab cosine of the angle here. Yeah, but yeah, and then let's rewrite these, right? So I'm gonna call this one C, just to make things nice. Yeah, exactly. Yeah. Well, you can just call it theta. Theta is just like something you don't know, right? So this is 73 squared is equal to opposite of A, right? Which is 32 squared, plus opposite of B, which is 47 squared, minus 2 times 32 times 47 times the cosine of theta. Cool. So now we just move all this over, which is kind of ugly, honestly. Like, why'd they do that?
Who got baby voice enabled? Is it working? 32 squared, yeah. Minus 47 squared. Okay, so that's 2096. Is equal to this mass. So 2 times 32 times 47, which is 3008. Okay, good. Cosine of theta.
Yeah, right? And then we just divide this over. So divide by negative 3008. So I get, what is it? This divided by this with a negative on it. So negative 0.696 is equal to cosine of theta. And then what's the last step here to figure out what theta is? Come on, blood, teach the math. Yeah. So inverse, yeah. Okay, so let me. You guys probably like wonder like what the fuck this like inverse cosine thing is, right? You're just like, I don't get it. Yeah, okay. It's actually kind of cool. This actually goes back to when Jamarcus was asking about operators and functions and stuff. Yeah, cosine is like a operator. It like does things to things. So if you're trying to figure out what theta is here, you want to get rid of the cosine that's attached to it. Some people will be like, oh, let me just divide by cosine. And like, no, that doesn't work because the cosine's not multiplying by theta. It's like it's acting on theta. So what you actually have to end up doing is you have to do the inverse cosine on both sides. That's really what happens here. It's the opposite cosine. So here's the way I like to explain it, okay? So let's say, for instance, I have 5x is equal to 10, okay? How would I solve for x? Anyone know how to solve for x? How would I do that? Yeah, it's close. Yeah. But I'll show you. It's the same thing. So if I wanted to solve for x here, yeah, Jarbifus, what would I do? Divide by 5, right? Cool. I'd divide by 5. Yeah, easy, simple. Okay. What's another way to say divide by 5 in terms of multiplication? So instead of dividing by 5, what would I multiply by? Multiply by 1/5, right? Okay. Here's another cool thing. Do you know how to write 5 as 1/5 as an exponent? What's up, Bob Rosses? Yeah, you're right. Good. Yes. 5 inverse. So 1/5 is the same thing as 5 to the negative 1. So do you see when you're doing that, right? 5 negative 1. When you're acting this on this goes away. And this strips away the x. So multiplying 5 inverse by that, this is like the inverse function hitting a function. This goes away. And then 5 inverse times 10, that's just 1/5 times 10, which is just 10 divided by 5, which is just 2. Yes. Yeah, you see that? Yeah. So, and you'll get into that because eventually you'll do stuff like this, like f inverse of f of x. This is just equal to x. Because what inverse functions do is they strip away the function that they're attacking. Right. Yeah, your teacher just told you to do it, but it helps. Yeah. So I want you to like, because this will come into play in later math classes. You're going to have to do inverse functions. So what you're doing here is cosine inverse is hitting cosine, and then these two are going away. So you're just left with theta. And then you're right. This is just doing, was it inverse cosine of that? Well, I got to multiply this by negative 1. And then inverse cosine. Yeah. Cool. Right, so that gets you 134.17 degrees. Yeah. Good. 1 sec. Let me see. A squared. Yeah. Okay. Cool. All right. Yeah, good. Glad that helps.
That's dope.
Yeah, you're welcome, dude. Nice. Did I give Jarbifus his credit yet? No, I still need to. Jarbifus. Good. And then he's got the weekly question credit. Nice. Okay, good. All right. Next up. Ooh, Patty. What's up, Patty? You want to come to stage? Come say hi, Patrick. What's going on, dog?
I've been waiting for so long.
I know. You seen our streams have gotten a little bit bigger.
Oh yeah.
He says, "Oh yeah, yeah." Let's go.
That's dope.
How's hockey? Are you still playing hockey with with Philip?
I don't play hockey with Philip.
Oh,
I'm
okay.
the soccer kid.
Oh, you're the soccer kid. Okay, that's cool, man. 30 viewers. Wow, nice. Yeah, we had. I think we had a couple raids. Ian Stuckey raided us, and someone else raided us. That was super nice. Yeah. Okay. Cellular respiration. Oh, this is kind of cool. This is for your bio class. You gotta learn this
Just
for bio.
just that whole thing, yeah.
Just the whole fucking thing, dude. Okay, that's cool.
Yeah, because I mean, our teacher doesn't do a great job of teaching us, and then the textbook, it's just all chemistry, and reading chemistry is an absolute nightmare.
I know,
So-
I know. You know, I had to talk about this actually in I was applying to some jobs, just to do like content creator stuff. And one of the things they asked about was how do you balance the 3 ways of teaching something? And they said it was like procedural rigor, conceptual question, and like application. So like procedural rigor is like how do I do the question, which I feel like is what a lot of teachers just teach. They just teach here's how you do it, and that's it. They don't give you any like context, and you're just like, well like what? Like it's cool to like learn the procedure of how to do something. Yeah, you'll get a good grade on the test, but it's like absolute dog shit if you have to learn anything past that because you can't build on what you know. But then there's conceptual, and some teachers start off real quick with the conceptual, which I think is also kind of scary because it's a lot of jargon and like terminology that you don't know, right? So you're just like, whoa, what is this? And then you just turn away from it. So you're like, screw this. I don't even want to learn this.
Yeah.
So I think application is probably the best thing to start with because application is what like gets you initially interested of like, wait a minute, why do I even care about this? And then once we got application, then you can show, okay, well, here's how you do it, and then here's the big picture. So your teachers, I think, either just jumping to conceptual or procedural. But yeah, lots of stuff here.
Yeah, she kind of like, so initially she introduced us to, I have my notebook out for
Yeah,
this.
yeah, yeah.
We got introduced. So this semester we started talking about water potential and all that
Okay.
stuff.
Yeah,
so
like
I understood
gradients
that
and stuff.
pretty well.
Uh-huh.
Yeah, like solute gradients. or
Gotcha.
whatever. And then our next like cell biology 2 is like what our unit is we got introduced to catabolic and anabolic pathways
Okay.
and like redox reactions, and then the electron carriers, like how electrons move,
Yes.
what moves the electrons. So
Mhm.
like that's NADH and
NADP, ATP, FADH, yep.
Yeah.
Okay.
So we kind of went through that little review over enzymes, and then kind of went into the physics aspect of it, of energy.
Sure, potentials. Probably electric
Yeah,
potentials and stuff.
potential and kinetic, and then like very basic law of thermodynamics, the 2 laws, like energy conservation and entropy. But
Yes,
like
entropy,
we
yeah.
haven't really applied those like much.
Okay.
And we've like seen like free energy graphs and stuff.
Yeah,
but
like Gibbs
not
free
really
energy
sure
or
how
something.
to Gibbs free energy. Yeah, that exactly.
Yes. Yeah.
And then so it's more so just figuring out how glucose gets to ATP, CO2, and H2O.
Sure. Okay. So there are a couple. You said a bunch of like good words of things. I heard like catabolic, anabolic. You probably did aerobic, anaerobic respiration, right?
Yeah, so fermentation, all that. Yeah,
Right,
We've
okay.
gone over those.
Right. Okay. So yeah, one of these requires oxygen. Anaerobic does not. In general, what usually gets asked, this is why I don't like biology as much because it's a lot of fucking memorizing, dude. Like
It really is. Yeah.
which I'm just like, bro, in these days, man, we can just look things up because you're not really going to do that much math. But this is probably what the main thing that this is like the ties everything. And first of all, I have to say, are we dealing with just animals or plants, right? Because then there's another whole thing for that as well,
Yeah.
right?
Yeah,
Well, you
it's
said
just a whole.
I assume cell respiration is animal cell respiration. They're not dealing with like
Well, I mean, it happens in plant cells too, but there's that extra step of having to get
Photosynthesis.
the glucose from photosynthesis. Exactly.
yes.
And we haven't gone over that yet.
Okay,
So
okay. All right, so we can just focus on
I,
animal
I
stuff.
think mostly we're just covering animal cells.
Oh, good. Okay. So I mean, this is
Yeah.
this is the main concept you have. Is
Mhm.
that
Yeah.
you have to have glucose, right? Which is sugar, basically,
Yep.
or carbohydrates. And the first reaction that always happens is called glycolysis, which you can kind of think of like glyco, right? That's the glucose, and then lysis means like breakdown, right? This is why, like, for instance, you ever seen like lysosome? Who was talking about lysosomes in the chat? Lysosomes, yeah,
Yeah,
break
we
shit
learned
down.
about those,
They're
yeah.
like the trash compactor. So
Break
that's what
down stuff.
glycolysis does, yeah. So what glycolysis does is it takes glucose. ATP, I like how they describe this as like money coins. This is kind of cool. This is like the cost of doing things. So
Yeah,
ATP,
it
which is
needs something to start.
it's a adenosine triphosphate, I think is what it's called, right?
Yes.
Yes. So that's what you need in order to do stuff. In the case of glycolysis, it takes a glucose thing, takes these 2 ATPs, and it produces 2 pyruvates. Okay. As well as more electrons and H pluses. These are useful because these are what we call like ancillary, or like they're like things you need on the side. You need free electrons, and hydrogen H plus is kind of like the anti-electron because it's H plus is just a single proton.
Yeah.
Is there a neutron in H plus? I don't think
No,
so.
I
Actually.
think it's just talking about.
Yeah,
no,
I think-
don't think there's a
I think it's just a
neutron.
proton. Yeah, it's just a proton. Yeah. So this is like the E plus and like the E minus and the E plus is kind of what I like to think about. But yeah.
Yeah,
So
Okay.
with these things, you're then able, yes, to do what are called different oxidation reduction reactions. Which, have you taken chemistry yet?
Honors chemistry in sophomore year, but
Okay, cool. So you did
I
redox
don't
then.
remember much.
Yeah. Okay. All right. Well,
But
well,
redox, yeah, like
right, oil-
reduction is
gain
gain, and then
ox is loss.
oxidation is losing.
Yes.
Yeah, because oxidation, how I remember it, is something gains oxygen, and oxygen is like the main like electron hoarder, so it takes the electrons.
Yes. It's a very electronegative element, is what we say. This goes all the way back to again.
So the periodic table, more
Yeah, yeah.
more to the top right.
Yeah,
the
more
more
to the top right.
electronegative it
But
is.
this is literally what I was dealing with I forget which student it was, but I was literally doing this electronegativity values. This is where everything's connected. It's all connected.
Physics, chemistry, biology. It's all
Yeah,
there.
well, they talk about like math is like the granddaddy of everything, right? And then physics is applied math, chemistry is applied physics, biology is applied chemistry, and then I don't know, like psychology is applied biology, and then
I don't know, this underwater basket weaving, or gender studies or something, I don't know. But,
Gender studies. Good lord.
but anyways, yeah, so is there any form of deuterium or tritium ions? That's a good question, actually. I don't think we have deuterium or tritium within our body. That would, like, be bad. Deuterium and
Lord
tritium
knows.
yeah, so he's talking about heavy hydrogen and, so I think is it H3 plus? I should know this, dude, because I did fusion plasmas, but
I don't know. It's yeah, it has to do with this deuterium and tritium. This is it. So it's like heavy hydrogen and like super fucking heavy hydrogen is what it is. So the H plus I think we deal with is what they call protium. That's just H plus. This is H plus. Or no, this is just H. Sorry, this is neutral. This is neutral hydrogen. What am I talking about? Sorry. Regular hydrogen. Hydrogen. These are called isotopes technically. Yeah.
Yeah.
Yeah, you're right. Yeah. So regular hydrogen is just a proton. Yes, which you're right. Yeah, cool. It's protium. Yeah, that's what we're dealing with which H plus.
So it
And
just
then-
deals with the mass of the hydrogen.
Yes. Yeah. Exactly. So as you add more neutrons, things get heavier, and that makes isotopes. But as things get heavier, they get more unstable, and that's what creates like radiation and stuff. So this is why, yeah,
Bombs.
tritium would not be a good thing to have in your body. I don't think. I mean, I'm not a doctor, but I don't think you want that. Yeah, not
We
good.
don't want explosions.
Yeah. I think there's something in like one of those like what was it, the Spider-Man films where like he's like precious tritium or something. I don't know. Yeah, that's what he's dealing with. It's an energy thing. But anyways, so yeah, you have these extra electrons and like anti-electrons, these H pluses, the protiums, because you need them to do oxidation and reduction. So when you have oxidation reduction reactions, that's like moving electrons and hydrogens, or like it's basically moving electrons from different compounds in order to either reduce something or oxidize something. Yeah. Studying is the new vibe, yeah. So I believe what happens is, okay, so once you have the pyruvate, right, then that pyruvate goes through what's called the Krebs cycle, okay?
Yeah.
And the Krebs cycle, requires all of these reactions to happen, right? This NADH and what FADH and whatever, and there's some sort of oxidation reduction, and you get another 2 ATP out of that, right? And then the last thing here is the ETC. The ETC is the main way, right? We make energy, and that just requires taking an electron and just bouncing it down a bunch of steps, basically. I love this graphic. It is kind of true, but electron transport phosphorylation, yeah. But this makes the most. This makes the 32 out of it.
Yeah, that I understand.
Okay, so
How
but
many?
the thing you probably need to know, like for your tests and everything, is this. This is always what they ask for you, right? They're always going to ask, like, okay, during what step, how much ATP is made, and then they say, like, what is required. So NADH is needed for glycolysis, and the part of this is the pyruvic transition, and then the Krebs cycle needs acetyl-CoA, right? Yeah.
Yeah.
And then the Krebs cycle, right, is right, and then this is the yield, and then this is the ETC is what it is. Oh, they don't, or wait, where'd they put ETC on it? Oh, the Krebs cycle
transition.
No. Where are they calling the Krebs cycle? The Krebs cycle makes 24. I didn't think it does. Does it?
No, it doesn't.
What the fuck? This is wrong, dude. What? I think they're including the they're including the ETC in this one. Yeah.
They have to. I don't know.
Yes, PCT. You're right. Radiation in your body is bad. We don't like that. Yeah. Yeah, it's this oxidative phosphorylation or whatever. Yeah. Okay. Okay. So that's just like a general overview of what it is of how to do it. I again, it's unfortunate that I think you have to just memorize this.
I feel like I do have the general overview.
Okay.
Of like
is there anything specific
like,
that's tricky to you, like a specific chemistry part that's hard?
Just like how the glucose molecule is broken down. So I understand that it's getting split into 2, and it becomes pyruvate, right? But
so
I'm
this
not
part?
understanding how. Okay, so with like glycolysis, right? It
Sure.
gets broken down.
Mm-hmm.
And then how that transitions to pyruvate with electrons, and then how the electrons are being transported through everything, pretty much.
Glycolysis.
Because I feel like the electrons part is the hardest part to understand.
Okay. Okay. Wow, this is cool. Okay. Here.
I mean, I don't know if I have to understand the exact chemistry of it, but
this is OChem. For anyone who wants to become a doctor, this is organic chemistry. This is what this is.
Good thing I don't want to be a doctor.
So yeah, if you want to be a medical doctor, this is eventually what you have to do. But yes, these are cool. These are rings, is what they are. A lot of things in life are rings. Yeah, carbon rings. Like benzene, gasoline, all that stuff is carbon rings. But yeah, okay. So I mean, this is way higher level than I think you have to do, right? But this is showing.
I would assume.
This is showing the individual steps that happen in order to turn glucose into pyruvate. So I'm imagining your teacher like distills this into like a couple more basic ones, right? Because even I don't know what the fuck PGI is. Like what's PGI? Like I see how they're saying that like, oh, this part of the ring breaks down into, I guess, into a hydroxide, cool, and then this is called like functional groups and like where things attack and whatnot. Yeah, Nick's like, my God. Well, yeah. So fair warning, if you want to be a doctor, like get used to it. This is what you have to learn. So that's probably like get you guys out of it. Okay, let me see. Glycolysis reactions. Let's just see if I can get like a nice picture of it. Okay, this I like this. This looks a little bit easier. Glycolysis explained in 10 easy steps with tons of ads that I don't want to see. Thank you. Okay. All right, and then this is the delta G. Okay, cool. Do you know what delta G signifies? I know it's Gibbs free energy, right?
Yeah.
But do you know what it means, right? Whether delta G is positive or negative?
I I think delta G positive is anabolic and the negative is catabolic.
Yeah, so it
Something
has
like
to do whether it's spontaneous or not. So
Yeah,
if
spontaneous.
delta
yeah.
G
I
is
still don't even
negative,
know what that means.
oh, okay. So delta G being negative means that the reaction will happen on its own. Like you don't have to put as much more energy into it, right?
Mhm.
Whereas delta G being positive, I think means that you need energy. One sec.
So would that be like that's like photosynthesis? I'm pretty sure.
Yeah, so negative delta G releases energy, which means it can proceed without an energy input. It's spontaneous. And delta G being positive means you need energy to do something. So you've probably seen these charts before.
Mm-hmm. Yeah, we
Right?
reviewed these.
Good. So see here how you're going from a high G to a low G. High gives free energy to low
Yeah.
gives free energy. This is a negative change in gives free energy, which means energy is released. However, do you see how there's a hump you have to go over, okay? In order to ride down the hill, right? So
Yeah.
sometimes you do need some energy to at least get up this hill. And what enzymes can do is reduce how steep this initial bump is. Okay?
Yeah, we had a graph where it was just like that, and there was a little line under it, and that was the enzyme line, the enzyme graph.
Yeah, exactly. Yeah. So this is why have you ever eaten probiotics like yogurt or stuff like that?
Mm-hmm.
Yeah. So those things contain enzymes that make it easier for your body to digest things down, to break things down. And so it makes this hill less, right? Yeah. So so the net reaction here releases energy here. The net reaction here, this is called exergonic versus endergonic. This one requires energy to do things. So when we get into here, this is interesting. A delta G is negative. Okay, cool. So this is turning ATP into ADP. Okay. That's kind of cool. Okay, this kind of makes sense, right? Adenosine triphosphate is going down to adenosine diphosphate. So you're releasing a phosphate, so you're releasing energy. Okay? And that's why the delta G is negative here. So this is how glucose turns into glucose 6-phosphate. Because what happens is this
Phosphate attaches to it.
I believe this is called, this is an alcohol. Is it ethanol? I think it's ethanol. Maybe methanol. Again, this is,
I don't know.
have you had to do ethanol and methanol in all these ones? This is, it's OChem.
I think, and I remember going over, in this class, we, anaerobic respiration, where it makes ethanol,
Mm-hmm.
but I'm not sure
Yeah, so
how
where
to
the
differentiate.
this is where the chemistry
the
comes
two.
from. So this is CH3OH. This is methanol. And then this is ethanol, CH2OH, and then this is isopropyl alcohol. You guys have probably used this third thing, right? You get a cut or something and you need to clean it out. This is okay. Don't use this. If you use ethanol, you end up going blind. So isopropyl alcohol is okay. Don't use ethanol. And this is actually, if you want to really go back to when they had the prohibition and people were making moonshine, right? They were making liquor in their bathtubs. Sometimes they would make a bad batch and it would end up having more ethanol than it really should have, and it would cause people to go blind. So this is the chemistry behind it.
That's where it comes
Yeah,
from.
they're all alcohols, but do not get drunk off these. It's not a good idea. Anyways, so yes, so that's why this right here gets a phosphate attached to it, and then you need energy to, I guess, create fructose, which is attaching another ethanol, I guess, here, more ATP to ADP, and then this turns into this fructose, whatever. And then these things start to need NAD to start breaking down what looks like. Oh, I think the whole ring splits in half, is what it does.
That's what glycolysis does.
That's super cool.
I think it's and then with how ATP breaks down, I think you need water to cut that bond. Hydrolysis of ATP to make it into ADP.
Got you.
I think.
Yeah. So then it splits, and then you have all this NADH stuff that's happening. But again, I don't think your teacher's going to require you to know this in depth. This is OChem. This is
No, I'm aware that like I'm not gonna need to know like the whole path of like where each like molecule goes and all that.
Okay.
It's just understanding how it moves and how it changes through the phases.
What's this? Respiration. Where's a picture of it? Yeah, it's cool. It has to do with all these like these channels.
That's the electron transport chain.
Yeah. And this is cool. This is physics because you have potential gradients.
Yeah.
Yeah. So when you have
So
like
that's back to like solute potential and water potential.
exactly.
and all that.
Yeah, which is kind of chemistry too, I guess. But yeah, when you have more H pluses in here than you do here, these H pluses want to go in. And so that's what requires I guess here ADP producing ATP, right? This is taking energy to move this way. Whereas I believe these are releasing energy as they move out of the cell. Oh, very cool.
I realized something.
What'd you realize, Ethan? Ethan, what'd you realize, dude?
I said we had 28 viewers here.
Oh, we do. Oh, we had a lot of viewers at one point. I think methanol is the one that caused trouble during the Prohibition. Ethanol is ethyl alcohol, the same we have in drinks. Not that drinking alone would make you blind. Oh, is that right, PCT? Yeah, one of them is bad. Maybe ethanol's okay? Yeah, don't drink that either. Yeah, that's bad. That's what Everclear is. It's not good for you. I remember doing shots of that in college, but we had to like chase it with maple syrup because it was so brutal. Okay. And then these are
I like this diagram.
Yeah, you like this diagram? Yeah, here we go. This is showing, right? So glycolysis produces ATP and then it releases electrons, and the electrons are carried by this NADH because this NADH I guess is positive, and so it wants to like carry an electron to make it neutral.
Yeah, it's NAD plus.
NAD plus, right?
So NADH.
Good. And then once you have that, those electrons get used within the citric acid cycle and this oxidative phosphorylation, ETC, whatever the fuck, to do the various steps of the citric acid cycle, like the various oxidations and the reductions. So, yeah, here we go. This is another good graph, right? So,
like that kind of cycle that they go through.
Right. So again, oxidation, right, is loss of electrons, right? Oxidation is loss. Yeah, okay. Cool.
And then reduction is gaining electrons.
Reduction is gain. Yeah. So this is why NAD plus becomes NADH, which is neutral. Because now you've gained this thing has become reduced. This thing has become oxidized. Yeah. And so that's NAD and NADH. It's kind of like the bicycle pedal. You're just rolling this thing around to just, move electrons back and forth. It's pretty cool, actually. I mean, I don't know. The human body is... Biology, starts to get me with, I'm like, oh, this is cool. But then I know from my classes that, bro, all these questions are just memorizing stuff. And I don't know.
It really is.
It just sucks. Because you're not really solving anything new. Which I understand when you get to higher level biology classes, such as microbio or, even OChem. That's kind of biology. That's when you really start doing the new stuff. But there's so much. Our body is so complex that we need so many years of basic memorizing just to get an overall viewpoint of what's going on.
Yeah. It is brutal. That's why I don't want to be a doctor.
Yes, yeah. But anyways, your teacher is going into a lot more depth than I have with my students.
I think it's not necessarily that the teacher's making us go more in depth. I think I'm just putting myself in that position.
Oh, okay.
I want to understand it more.
Oh, that's cool. No, if you want to understand because you're generally curious, cool, man. Do it. All for it. Just make sure you do well in your classes too. So, figure out what exactly your teacher wants you to know, which in general I think is usually the amount of ATP created in each step, what's required in each step, and what are the byproducts of each step. So
yeah, because she's she's been teaching us how it gets to where it is, but I don't think on the AP test, for example, it's gonna be that in depth.
No. The AP test is literally just gonna ask you, okay, during this step, which one turns into which. You're like, cool, done. Or they're going to ask, you know, how many electrons do you get out of this, or how many ATP do you get out of this? So my best advice to you would, you know, make like a table, make some flashcards. I guarantee, if I go to like Quizlet cellular respiration, bro, I guarantee you there's one here. Oh, there you go. Look, it's a
You'll
flashcard.
find something.
Yeah, right?
There's always something.
There's always something, dude. You know, great. Yeah, so you could just literally just click this and just be like, cool, photosynthesis. What type of, whatever, blah. What happens when they're broken down? Energy's released. I don't know. This is actually a little bit too simple, but yeah. You get it. This cool question, though. I appreciate it, dude. Did I help you out a little bit more with, like, big picture of what's going on?
Just, yeah. That's what I've been trying to do. Just, like, getting the big picture.
Yeah.
And all that.
Yeah.
Been watching a lot of videos on it as well.
Yeah,
but I was
YouTube.
gone for the
You guys
weekend.
are so blessed, bro. You have YouTube, dude. I didn't have fucking shit, dude. When I was back in my day, we didn't have YouTube, bro.
You had books.
We had
That's all.
books. I had to go to the goddamn library and like find this.
Awful.
But you guys have like all the beautiful like animations and the videos and the TikToks, so it's very cool what you guys have.
Yeah, that does help quite a bit.
Nice. Okay, cool. All right. Good question there, Patty. I hope to help you out. If you ever have like specific questions on like chemistry stuff and whatnot, yeah, just drop the screenshots. I'm happy to explain them. Cool. All right. Nice. Good to see you, Pat.
Yeah, it's good.
All right, Taco Cat, what's up? Cool stream. Cheers on sharing knowledge. Yeah, thanks, man. And honestly, like PCT, like I learn things too. I'm a big believer in like lifelong learning and whatnot. You know, I have my PhD in physics, but I love learning all the other facets of science. And so every stream, I learn something, even just going over a topic with one of the students, or you know, people like you say something in the chat, and I'm like, oh, I didn't know that this is this, or you know, I forgot that tritium is this, but deuterium is that. So it's a, you know, it's better than watching some chick with tits on a hot tub stream. You know, I don't know. Trying to do something good on Twitch. Raw, where is it? Taco, where you at, dog? Where's my boy Taco? He may be off playing Fortnite. Oh, Taco Cat is here. Okay, cool, dude. All right, nice. All right. Okay, arithmetic sequences. We already did arithmetic sequences for you, dude. We already did arithmetic sequences. Okay, yeah. Let's do geometric sequences. Yeah, because before, yeah, I know. What was it? Where were we last time doing stuff? Yeah, remember this? We already did all the arithmetic sequences. Yeah. But let's do geometric. Okay. All right. I'll be here till 9 EST. Okay, Teacup, I will try to get you in time. This is why you have to be present when I call on you, because otherwise I got to keep rolling. Okay. All right. Let's say we have this type of sequence. Let's say we have 3, 12. Well, this is getting actually kind of complicated. Whatever. 48. Blah blah blah. Yeah. Blah 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 blah. Okay. Can you guess, Taco Cat, what the next term in the sequence would be? Sequence. Like, is there a pattern? Yeah, what do you see? Yeah, Monkey, it's okay. What do you see? What's the pattern? Multiplied by 4. Good. Yes, good. You see this is times 4, right? This is times 4. So the next one, right, is probably 48 times 4. Do you know how to do 48 times 4? Like really quickly in your head? Kind of a cool way. Just a little quick trick. I like to think about this as like 4 times 50 minus 4 times 2. So, oh, yeah, no, it's 200 minus 8, which is 192. Yeah, 192. Yeah, not 150, 192. The reason this works, right, this is the same as 4 times 50 minus 2. This is the same as 4 times 48. You're just doing each one individually. I just do it on numbers that I know. Like 4 times 50 is an easy number to do. In terms of cellular reactions, yeah, I can do that. I can do that later. Yeah. I think that's cool, Jelly Pops. Did you see earlier on the stream? I was literally just doing that with who's it? Patty. I was doing it with Patty literally just earlier. Okay. So, this is what we call here. This is what is called the common ratio. Okay. And just like before, right, with arithmetic sequences. Where was that? Right here, right? Where we learned, right, what A sub n was. And we also learned what S sub n was. These were for arithmetic. We also have similar formulas for geometric, okay? So, let me remember what they are. Geometric series formula. Yes, this is a cool one. Oh, okay. This actually has all of them. Save me, please. Quizlet. Quizlet's great. Oh, you know what? Jelly Pops. You know what's a really good idea? Join our Discord if you haven't already, Jelly Pops. And if you have just for me to help you, the easiest. If you have like a specific question that like doesn't make sense, you can just like take a little quick picture of it. And then what we do is people just dump screenshots of their questions in here. And then so this is an easy way for me to know like exactly what I can help you with the best, you know. Yeah, growth rate, or you know the classic one I'm going to do, PCT, is if I give you a penny, but I double the amount of money you get every day, right? This is the classic one. Yeah. Or we could do the accelerating at a rate of 50%. Yeah. Yeah, okay. Okay. So this right here, Taco Cat, this will tell you what the nth term is in a sequence. R is the what is it? Is the common ratio. And then A, this is A sub 1 is what it is. That's the first one. Okay. All right. So let's say Monkey, that I wanted to know what is the actually, no, here's a good question. Here. So, cool. And the other way to get common ratio is to take two things and divide them by each other. Or there's another way where it's like if I had the 8th term and like the 3rd term, right? We've done that one before. That's another fun one. But here, let me start you off with like a basic one. Let's say let's say on January 1st, I give you $1, okay? Every day afterwards, I give you twice as much as I did the day before. Would you rather get $10,000 up front or play the game of doubling the amount? This is a good one. Play the game, 1,000%, right? Yeah, right? It would be great. Yeah, they just double the amount they give you every time. Oh, it's a sign from the universe? Yeah, thanks, Jelly. That's why, we try to be out here just helping people with stuff. Nick says being up front is better. All right, well, let's figure it out, okay? Let's figure out. So, the first thing we could ask, right, is... Let's say the question is, like, how much... do you get on the 7th day? Okay? Monkey, do you know how to calculate how much money you would get on the 7th day if every day I double the amount I'm giving you? Right? So the first day I give you $1. Second day I give you $2. Third day I give you $4. Yeah, not arithmetic, because look what's happening with the sequence, right? So I have $1 on the first day, then 2, then 4, then 8, right? Then 16. What if he doesn't show up on day 12? Yeah, do you see this? Yeah, okay. 6, 7. So you can kind of see. You can see right here, right? The amount you get on the 7th day is 64. There's a way to also do this in terms of the equation, which is that a sub n is equal to a sub 1 times r to the n minus 1. All right? In this case, we're looking for a sub 7, right? I'm looking for the 7th day, which is equal to the amount you get on the first day, right, which is 1, times the common ratio. What's the common ratio here, Taco Cat? How much is it changing? Doubling. Good. So this is 2, and then n minus 1, right? That's going to be 7 minus 1. Okay? This ends up equaling 2 to the 6th, which is equal to 64. If you don't believe me, here's a calculator. Come on, calculator, let's turn it on. 2 to the 6th, 64. Yeah, do you see that? Okay. Now, so that's how much I gave you on the 7th day, right? What if I wanted to calculate how much total money I've given you up until the 7th day? What do we use for that? What type of equation do we use for that? It's not an a sub n one. Well, let's see. I gave you 1, then I gave you 2, then I gave you 4, then I gave you 8, right? You got to add these all up, right? This is like 3, 7, 15, blah, 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 blah. There's an easier way to do this. It's to calculate what's S of n. S of n is the sum, so adding up all the numbers up to that day. So in this case, the equation is a sub 1, and then it's r to the n minus 1 over r minus 1. This is the equation for the sum. So if I want to know up until the 7th day, right, that's going to equal the first amount I got times r to the n. So remember, r was 2, n is 7, minus 1. And then this is over r minus 1, 2 minus 1. Yeah. Okay. Yeah, okay, good. Okay. So that ends up equaling, so 2 to the 7th is going to be 128 minus 1, right? So this is 128 minus 1 over 1, which is equal to $127. Okay? So after 7 days, right? On the 7th day, I gave you $64, but in total, you've gotten 127. All right? So maybe let's see how much money you would have after 31 days of me doing this. Okay? Because that's our question, right? The question is, should I give you 10 grand up front or play my game where I double the amount I give you every day for a month? Double it, give it to the next person. Have you guys seen those things on TikTok? Double it, give it to the next person. That's what this is. This a geometric series is double it, give it to the next person. I think I saw the one where they're doing the smoothies, but then like where the fat person just eats all the smoothies or something. She's like, I'll take 4. Okay. Anyways, okay. So 2 to the 31 over 1 over 2 minus 1. This is a big number, 2 to the 31. You want to see what this turns out to be? It's actually pretty cool. So 2 to the 31 is this. Do you see this? 2, 1, 4, 7, 8, 3, 6, 4, 8. And then it's all divided by 1. So it's the same thing. So you're rich? Yeah, dude, look at this. Like, bro, what? Like, okay. So if we played this game, okay, after a month, you would have $214 million, $783,648. Yeah, almost $215 million. Yeah. It's crazy. Yeah. He says I'm set. Yeah, I think most people would be set with 200 mil. I'd definitely be set with 200 mil. That's a lot of money. But yeah, this is why geometric series are very powerful. This is also why things such as compound interest like really bite you in the ass in terms of credit cards, because they work on the same principle of kind of like being geometric. Gold, I think you should donate to the poor. Yeah, if I had 200 million, yeah, dude, I already donated enough to you guys. Anyways, let me move on to some other questions. I hope that was cool, Taco Cat. I hope that showed you something dope.
That's dope.
Mm-hmm. Where's my weekly question roll? Okay, cool. All right, let's keep rolling. Let's see. Horizon, are you here at Horizon? At Horizon? Yes, you are here. Yeah, you are. Oh, dope. Okay, cool. Nice. I see you in the chat. You're good. Do you want to... You can come talk on the stage if you want, or you can just talk in the chat. Whatever you want to do. All good. You can't escape me. All right, Teacup. No, don't worry. I will do yours. Okay. Oh, then Ian Stuckey. I see you got a good one down there, too. Look at that. The sum of 100 given real number is 0. This is something I need Penn Center for, dude. The FNC is people get like millions of dollars. Do people pay taxes for it? Yes. Yes, everyone pays taxes. The government always gets their money, unfortunately. Okay. I'm finally able to touch the backboard. Nice, dude.
That's dope.
Yeah, and taxes on winning things like that are very high. They're usually like 30 or 40%. But it's just a game? Yeah, but you're making money. The government don't care. If you're making money, then... Oh, you're okay. You're okay for a reason. Okay, here we go. When a circular lamina, of radius r is cut out from a circular lamina of radius 2r plus 3... Oh, okay. I assume this is... Dude, what is lamina? Lamina sounds like a weird thing. But do they mean just like a circle? The area remaining Portia is 27 pi squared. Show that r satisfies the quadratic equation that, and by solving it, find the value of r to the nearest decimal by considering find the circumference of the small lamina. Okay, very cool. Yeah, I think lamina just means like circle. Okay. Okay, so this massive thing right here, that's 2r plus 3. This one is r. So if we want to find the area for reason, right? Can I just take like the area of the big one and then subtract it from the area of the small one? Think so, right? Okay. Area of the big one is going to be pi times r squared, which in this case is 2r plus 3 squared. And then we're going to subtract it from the area of the small one, which is pi r squared, right? Okay. So, and then this is... And then this needs to equal... Oh, they already tell us. I need this difference to equal 27 pi. Okay? So, first thing I probably want to do is just expand all this, okay? So, this is a good trick y'all should know. If I have a plus b squared, this is the same thing as a squared plus 2ab plus b squared, okay? Where this thing is a, and then this thing is b. It just makes it a lot easier in life to do these types of expansions. So, and you know what I'm going to do? Even before I even start here, right? I'm going to get rid of all the pi's. Do you see how I have pi times this, pi times this, pi times this? We can just get rid of these. Okay. All right. So expanding this out, that's going to be 4r squared plus 2 times 2r times 3. And then plus 3 squared. And then this is also minus r squared is equal to 27. Okay. The king has cancer. Yeah, I did hear that. It's unfortunate. King Charles. He's got prostate cancer, I think. Cancer comes for us all eventually. Okay, so 4r squared minus r squared. That's going to be 3r squared. Combining all this, 2 times 2 is 4. Times 3 is 12. 12 times r is 12r. And then plus 3 squared is going to be plus 9 is equal to 27. All right. I see everything here is a factor of 3, right? So let's pull a 3 out of everything. So divide by 3, divide by 3, divide by 3, divide by 3. Now we get r squared plus 4r plus 3 is equal to 9. So this gives me r squared plus 4r minus 6 is equal to 0, which I think is what this was in. Yep, good.
Nice.
So we got that right. Okay. And then find the value of r to the nearest first decimal place. Okay. This unfortunately doesn't factor nicely, does it? No, I don't think so. I got to think of like what multiplies to 6, negative 6, but adds to 4. It doesn't, right? We got like 1 and 6, 2 and 3. Yeah, nothing's going to get me 4. Okay. I got to pull out the big gun. So quadratic formula, if we remember, that's going to be negative b plus or minus the square root of b squared minus 4ac all over 2. Okay. So that's negative 4 plus or minus square root of 16 plus 24 all over 2. So negative 4 plus or minus square root of 40 over 2. And then breaking down square root of 40, this is the same thing as 4 and 10, which is 2 and 2. Pair comes out. This is 2 square root of 10. So I have negative 4 plus or minus 2 square root of 10 all over 2. And then I can start canceling 2's. So since there's a 2 here and something of a factor of 2 here, this goes away. This becomes 2. So we have negative 2 plus or minus 1 square root of 10, which is just square root of 10. And then they told me to approximate square root of 10 to be 3.16. Okay. So let's call this 3.16. Okay. Ooh, what do I gotta drink? Thank you. Okay. I want the positive solution, right? Because if I do negative 2 minus this, that gets me a negative radius. Don't want that. So I'm going to do negative 2 plus 3.16. And so that's going to be equal to 1.16 is equal to r.
Nice.
I believe. Okay. Then if r is equal to 1.16, the circumference of the smaller one here is just 2 pi r. In which they tell you that pi is 3.1. So that's 2 times 3.1 times 1.16. Which is super fascinating. They give you these approximations, but then you still have to use a calculator to do this. So, whatever. I mean, like, I'm cool with the approximations, but then, like, what? I still need a calculator for this one. I mean, I guess I could do that by hand, but that would suck. I don't want to do that. 3.1 times 1.16. Good. And that's equal to 7.19. And you're done.
That's dope.
You don't get to use calculators? Oh, okay. Well, then unfortunately, you would have to do this by hand, right? So this would be 6.2 times 1.16, which, do you remember how to do this? Right? This becomes 332063996. So 2, 9, 12, 1, 7 point. Oh, did I do something wrong here? I did do something wrong here. Fuck, I did wrong. Sorry. Oh, this is 2.32. Duh. There we go. There you go. That's right. 7.192. Yeah, makes sense? Cool. Awesome. Nice. Good job. Oh, what's up, Destiny? For a reason. Nice. Take my calculator off. Hot stuff for nuclear fusion turbulence. Yes. I did basic plasma fusion, but yes. The ideal goal there was to eventually do... I wanted to maybe help out with nuclear fusion, but then I saw that ITER was delayed another, like, 20 years. I'm like, bro, I'm not waiting around for this, dude. What? Yeah, it's gonna be a while. But yeah, no, I enjoyed it. It was cool. It's actually funny, PCT, like, kind of like where my story comes from is, so they don't really pay you that much in grad school. I mean, they pay you something, which is nice, but, like, Los Angeles is not cheap. So I had to tutor a lot on the side, and as I did that, I started realizing that I really just enjoy teaching, and I like making a fun thing out of it. So that's why after I got my PhD, I kind of said goodbye to academia and doing plasma physics research, and I said, oh, let me go start a nonprofit to teach kids math and science on, like, Twitch. I feel like that's more fun. Gonna finish the paper after the stream. Yeah, nice. Yeah, here, let me save this for you for a reason. Sorry, I forgot to give this to you. What's up, Destiny?
Yo, what's up?
How's the college life, dude?
It's good, man. It's good. I'm actually trying to go 4.0 this semester.
Hey! Nice, dude.
Thanks, man. You know that troubling roommate situation I had?
Yes, the slightly, I don't know, everyone's autistic, but yes, yeah, that one.
Yes. Well, he moved out, and so now I have like a full. Like, I turned my room. So first of all, his bed is now a couch.
Okay. W.
And
Nice.
totally rearranged the room. I have 2 desks at my leisure now.
Do you want to show us? Do you want to show us? Are you in your room right now? Do you want to show us? You can show us.
Here, let me hang on. Let me do one thing quick.
Yeah, it's like, let me go put some stuff away. Yeah. So, I know a lot of you kids on the stream here aren't in college yet, but maybe Destiny can show us what like a college dorm looks like.
Oh yeah, for sure.
I forget what college dorm is. It's kind of like your bedroom, but maybe a little bigger. But then sometimes you share it with someone, and then like I don't know.
My bedroom at home is like 10 by 13.
Yeah,
like, I can fit a lot of stuff in here that I can fit in my bedroom. But when I was sharing it with somebody else, I had like of walking space. I had probably like maybe like 40 square feet. Like it was like.
Oh wow. Yeah, I know. Yeah, because you got to put all the stuff in. Yeah.
Okay. Let me just turn on my camera.
Oh, you're good. There you go.
Hello, y'all.
Yeah, there we go.
Dorm.
What's up? There you go. There's Destiny.
Dorm guys.
Ah, there you go. Okay, cool.
Sink.
That's there's like a prison sink, dude. What? That's terrible.
The walls are made of bricks.
Oh yeah, okay. That's very much a dorm. Yeah, okay.
So we got the trunk. So first of all, this whole side area has been opened because my roommate moved out. The bed used to be
okay.
The shelves are now both mine, which has been beautiful.
Nice.
I've got my books here. I've got all the books that I've read this semester up here.
Oh, that's good.
Air freshener.
Air freshener, very much necessary. Yeah.
Okay, so guys, when you get to college, I wish someone had told me this. If you got 2 dudes living in a space and they're not obsessively clean, and I do mean, like, if they're not, like, really clean, your room is going to smell like you had a sewage fire in the center of it.
Oh, God, dude.
So what I had to do, this girl walked in and she's like, listen, if you were coming in here for things to happen, I would leave immediately.
Yeah,
like,
red flag. Yeah.
So now I'm like, okay, now I need to fix this shit. So I literally went through and I washed a piece of clothing that I think had ever been worn.
That's good.
I had like stuff that I put in my shoes. I went and I bought air freshener. I washed my towel, like shower caddy thing. So that's
okay.
Like, and now,
but you don't have a bathroom in your room, right? You have one like down the hall that you have to go use.
That's more sophomore stuff.
Ah,
so we got this.
Okay.
We got this shoe rack. I highly recommend a shoe rack.
The shoe rack's nice. Yeah.
Shoe rack, like I like shoes that fill every single thing in that shoe rack. It's beautiful.
You got a lot of shoes, dog.
And, yeah. So we got the 2 desks. So listen, my floor looks like this.
Oh no! Why is the laptop on the floor though, bro? What's going on here?
hang on. Hear me out.
Okay.
Hear me out. Laptop's on the floor. My floor looks like this, that my desktop can look like this.
Oh, okay, I like that. It's like my hands look like this, so her hands can look like this, but it's like
Exactly. So the floor is a total freaking disaster so that I can have monitors, a lamp, and my keyboard fully set up. I've actually got my guitar hooked up to my
oh,
laptop.
sick! Yeah, the
Everything-
music stuff.
I've got the keyboard and everything. I basically turned my laptop into a desktop. Like I've got my interface down there for music stuff.
Yeah, the Focusrite. I see it.
So basically have like a full-on setup desktop. So then I've got my desk that I keep clear for writing. right?
Okay.
This is like
And
two
but
desks
this used to be your roommate's desk, but because your roommate moved out, you now have what we call like mega desk.
guys, bully your roommate, they'll leave.
Bully your
so
roommate, they'll leave.
kidding. I'm so kidding. It was fine.
And this is the couch. And this is the couch you've now created.
This is now the couch, which used to be his bed. So I've got my guitar sitting there, and I've now made a piano. You know what I ordered today, bro? I got
What'd you
a
order?
sustain pedal. I had a
Oh,
piano
nice.
For 2 years
Wait, how
had
have you been playing piano without a sustain pedal, dude? What? Excuse me?
because I just hold the keys down if I want to sustain.
Oh no.
Yeah, no. So
Okay,
we've got the
cool.
blind curtains for your dorm, guys, because the blinds are like really like
Yeah,
those aren't
necessary.
blinds. This is crap. Here the windows are really cool. And they
Okay, show us the
prevent
windows.
you out of them, which is awesome.
Oh, do they have the anti-suicide windows where they don't let you jump out?
Side window. You are absolutely correct.
Yeah,
We've got
yeah.
March. So guess how much fresh air I get. That much.
That's all you're allowed, dude. Yeah, it's funny. College dorms start to represent prisons at some point, and you kind of wonder, like, why am I paying for this? Like, why am I paying to live in a prison? But yeah, that's.
Then I have that, and that's
There you go.
like
Okay. That's a decent amount of space, but not
yeah,
enough
no,
space to
but
unalive
my
yourself.
My question being is that like I could totally like kick that screen out. So why can't I just like?
I don't know. It's
I
probably
don't know,
because like
man.
too many drunk kids probably tried hanging out the window, and then that's why they had to do it. That's college. It's like
That sounds right.
cool, man.
Yeah. So I've
Nice.
got books, on the desk, and a little mini light. Get a mini light that clamps onto your headboard, guys.
Okay.
This thing has saved me so many times. Got jackets. So what I did is I didn't set up all my shelves. I have two shelves. I have shelves down here that I don't actually have my on, and then I've got this surface which I keep like everything else.
Well, you
on
have more
there. I
space
hang
for
my
storage later, dude.
from the poles of the shelves, which has been really freaking nice. And I've got ocean tigers.
Nice. I like ocean tigers. That's cool, dude.
Adventure time.
Adventure Time's also dope. Nice. Cool.
I've got I mean that's pretty much it. So I've got my own little mini fridge here. You always take a mini fridge with you to college, and you know it's just the mirror opens. Pretty
Sick.
nice. Honestly, I say dorm life is probably the best thing that ever happened to me.
It is.
Gotta
No, the
be real.
dorms are cool. The dorms are pretty cool. Everyone should, when you go to college for your first year, you definitely should be put into a dorm because it's an experience. You learn how to live with someone else, which is a big life-changing thing because you have to suddenly
God.
adapt to somebody else's, like, all their, as you know, right, all their tics and all their behavior stuff.
Yeah, no, my roommate. I'm a very talkative guy. Like me and my mom, like whenever we see each other in the house, like we say stuff. We say good morning. We ask her, like, shut the- Hey, do you
No,
wanna
but
talk about it?
No, yeah,
Not
you
me.
found out. Yeah, he didn't want to talk. Yeah, but you learn that because the world is like this. Is that people are different, and you have to learn how to adapt to like people coming from different upbringings and backgrounds. So yes,
No, and I totally agree. It was. We played Minecraft together for like 3 hours. That's how we decided we would be good roommates. If we can build a house, you know what I'm saying? Like it was, but that didn't really work out.
yeah,
Mom's like, well, you don't really know me. I'm like, Mom, it's gonna be fine. It's gonna be fine.
Yeah,
Relax. You
yeah,
know?
yeah.
Yeah. So, don't do that.
Cool.
Listen to your mom's kid. She's probably one of the wisest people you know. Yeah. No, I mean that's pretty much it. I've got plenty of space now. I took my longboard with me. I
Nice.
have a sign that said "Wizards only beyond this point."
I like that.
Yeah. So that's my dorm. I've got a miraculous amount of space.
Yeah, you were fortunate with having a shitty roommate and then him moving out, and then hopefully this is the reward now for you having to deal with like having a bad
Well,
roommate
they
your
might
first 6 months of
somebody
college.
Like they could email me and be like, "Hey, someone's moving in an hour."
Oh, I see. Oh, you have an opening. Oh, so yeah, someone could come in and take your newfound space. Uh-oh. Well, enjoy it while you have it, Destiny, dude.
Thank you. Yeah, no, and I'm worried about that because like people are still in like the honeymoon phase of the roommate. But my floor has a really bad reputation for being loud.
Okay.
And I'm 8th floor of the towers, and so it's getting warmer, meaning that it's going to be hot as in here.
Yeah.
Because
There's no AC.
in the freshman.
No AC. Well, tell everyone what college do you go to if they're wondering, like on the stream, what college do you go to?
The College of New Jersey.
College of New Jersey.
Got-
Okay.
Great school. Really, honestly, I this is the only school I applied to, and I really don't have any regrets about that.
Okay.
People here are so different. Like, I stayed in state, man. I moved an hour south, and people are so different. Like,
Yes.
My family is very dense, right? And
Yeah.
I feel like in dense populated areas, people learn pretty quickly that if somebody doesn't know what they're talking about, you basically totally disregard everything they're saying.
Sure.
They don't do that in South Jersey. Everybody takes everything a lot more personally.
Mm-hmm.
And it's just the whole thing is really, really. You got to find your people.
Yeah, I agree.
Like, I see. So what I did was to find the people who were a little less sensitive about things. I went to the club where they beat the crap out of each other with sword. Best
Oh, okay.
thing I
So you
ever
did fencing. You joined the fencing club?
No, I joined the Manhunt Club.
The Manhunt Club. Okay.
Manhunt.
Okay.
Where they've got like swords, and we essentially.
Oh,
we-
I know
we
what
just-
Manhunt is. Oh, wait a minute. I know exactly what this is. Wait.
Yeah, well, we don't really we play a different kind of Manhunt. Like there's a different objective involved because we've got a lot more people and a much bigger campus to work with.
Yeah.
We'll literally just go around. Like if I hit you with the sword first, you're out. You've got to go
Yes.
touch this lamppost, hide yourself. And so we play protect the president. So you have a team that defends your president. You've got a team that attacks the other people's president, and you kind of like can switch as necessary. It's really awesome. Long story short, I knew I would be finding people who are a little less sensitive there.
Yeah. You find your people.
Not to say that I'm like a total asshole that I just go around saying things just to see if I can piss people off. It's just different here. Like if I say something and I don't necessarily realize the implications of that, there's a certain type of people that will be like, oh, well, maybe he just didn't know XYZ, and then there's a certain type of people that you will find in tiers.
Uh-huh.
Got to work out who you belong with, and I'm not saying either of those are wrong. You just gotta figure out.
Finding clubs is always a good idea. Always a good idea. Well, it's like, I gotta finish someone's question real quick here, Destiny, before they leave. Cool. Very good. Thanks for the tour, man, dude. I appreciate you like showing that for everyone. It's cool for the kids to see like what college can be. But yeah.
Oh yeah, man.
We'll talk more about stuff.
A waste of time, in my experience. Like do well in high school. Do well in high school, but college is where. I always said I never wanted to kill myself for the A. Here, I study, I work, I sleep, and it is the best life I've lived thus far.
Yes. That's why kids, go to college, dude. That's what I say. Like, you know,
Much better than high school.
get good grades now. Go to college. It's much better than high school.
Yes.
Okay, cool. Thanks, Destiny. I appreciate it, dude. Later, dude. All right. I have a 2 in Spanish class now, and progress reports get submitted. Okay, cool. Okay. What's up, Falcon? What do you need here? What do you need help with? I just need help with the probability portion. Find T-calc, make confidence interval, bang my head as well. Okay, what's up? You mean T-critical? Oh, no. This? Oh, man. Ugh. The fuck is all this? I'm looking at a lot of data here. We know T-critical. Okay, cool. Where is T being calculated though? Oh, here we go. Oh, this. Uh-huh. Okay. Okay, but I have to know a little bit about what's happening here. Are we doing the distribution of... Wait, what? Convert average rate hard to total revenue for stand. Less than 30 T-test, T-critical. Uh-huh. Okay. Yeah, can you get the... Yeah, I need to see the whole problem. Yeah, I'm seeing a bunch of data here, and I have no fucking clue what the data is related to. Yeah, I need to see the problem. It's my homework. All right, 19. What? Did someone submit this as their homework question? QVNTT, you troll. Someone posted this as their homework question in my Discord. Like, excuse me? Nah, show me the cursive one. I want to see the cursive one. All right, let me see. Falcon is posting it. There we go. Thank you. Okay, yeah, this is what I need to see. All right, let's go. Okay. The proposed harvest will be a low thinning to residual basal area. Low thinning is this. Oh my God, this is so much. Yeah, I forget that you're in like forestry college. I just hope that this operation will generate 6,000. Okay. Measured every two. Oh wow, dude.
That's dope.
Thanks for the gifted sub. Oh, we're at 11. Hell yeah. Oh, I gotta make a new goal now. We want to know if we'll make at least 5,000. Okay. Convert the average harvest biomass to pound into total revenue. Okay, good. Okay. So you get this. Is this revenue? Are these revenues you have here? Are these the revenues, Falconer? All good, Jelly Pops. Yes, yeah, please join our Discord, Jelly. Please join. Or that's the best way for me to, because I have like a queue of questions I have to go to. I'll be here for a while. But, and if you want to know what our schedule is, there's our schedule. So I teach Monday, Tuesday, and Wednesday. Just show up at whatever those times. Throw a question in on our Discord, and I'll make sure to get to it. Revenue is a little conversion sheet below. Okay. Pounds per acre, tons per acre, acres per stand, dollars per ton, gross revenue. Where it shows the means. Okay. Basal area, stem count. Stem and branch. Okay. Yeah, there's just a lot of jargon here, unfortunately. Yeah. Yeah, you're welcome, guys. Like, what is this? What is this? What is it? Removed biomass. Okay, on the plots. But then I have no clue what DBH class is. That has something. That's some forestry term that I don't know about. And I mean, this makes it look like, okay, so this is the amount of pounds per acre, which you converted to tons, right? You just divided by 2,000. I get that. And then acres per stand. So then you multiply these two to get tons per stand. Okay, okay, cool. And then dollars per ton. Okay, 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 okay. So then this is the revenue, because you make... Wait. How did this number go up to this number? Oh, dollars per ton. No, I see. Okay, cool. Got you. Okay, so this is the mean. Okay, but what are these numbers here? I guess what is this? What is like this 15648? What are these things? Well, okay, to figure out T-calc, right? I need to figure out here. If you want to figure out like a T-score, this is always going to be whatever your value is, right? X minus mu, all over what's going to be sigma over the square root of n, probably, is what it is. How big the trees are in girth. Okay. Yeah, so what you want to do, okay, and there are nine plots, so I'm trying to think how, like, you stratify this. Like, what's the... Okay, and then where did this come from? Where's this 9157? Okay, that's all these. Okay, I think I'm starting to see this. Uh-huh. Okay. No, I think I see it. Okay. So the mean amount of money you're saying that they made is this, right? It's 1,300. Yeah, average of all the diameters. I get it. And then you're taking that and then you're converting that into a revenue. Okay, cool. Got it. Okay. So you want to know... It is hoped the operation will generate at least 5,000. Well, it's not. Bro, it only generated on average 1,300, right? That's terrible. Yeah, okay. So this is what it is. Okay. It's the score you're looking for, which in this case is 5,000, minus the mean, which is 1,300.3, right? All over the standard deviation, which standard error here, right? Cool. It's 496.6. And then it's divided by the square root of n. And yeah, you're right. I think it is... Is it n minus 1? One sec. I gotta remember that. T-test. T-score. I think it's just n. Yeah, it's over the square root of n. Okay, cool. All right. Great. Yeah, okay. So, and there were nine samples? Okay. Sure. I see. Each plot is like a sample. Okay, I see how this is stratified. Got you. Okay, all right, cool. This is your T-score then. All right. So, I get it now. I just had to learn about the trees. So it's that, and then divided by 496 over 3. This is going to be a huge t-value, dude. Yeah, it's a t-value of 22. 22.37. Yeah. This is really bad. Like, this is, like, not probable. It's, like, never going to happen. Yes, okay. Yeah, because... Well, yeah. So for a t-distribution, right, you can look for a t-table. Well, actually, yeah, never mind. Sorry. You're right. You use t-critical. But for... What was it? n-1 is 8. Yeah, look at this. Okay. For there to be a 0.0001% chance of that happening, you're already at t equals... You're only at, t equals 5. So t equals 22 is like 4 times that. It's basically never going to happen. Yeah. Unless something is wrong here with the... I mean, I trust that this stuff is correct. We want to calculate to be smaller than t critical to fail to reject... No. So you want it to make more, you want it to make at least 5,000. Okay, so this is how I see the distribution, right? If this is like revenue, right? You want it to make more than 5,000. So it on average makes 1,300. That's what you're seeing here, right? You're seeing on average it makes 1,300. So the probability of something doing 5,000 is like just this, which is very, very, very small, right? So the probability that it makes less than 5,000 is very true. It's very much going to make less than 5,000. Yeah. Yeah, that's what you can say, like, yeah. There's no way. Yeah. Does that make a little bit more sense? It's a weird question, honestly. Because it has a lot of, like, jargon in it. But, like, once I got it down to, like, okay, here are the samples, here's the mean, here's this, then you can just do it. Okay, cool. Awesome. Good. Cool. Yes, Destiny. I love that. Telling people go to college. Wow, thanks for follow, guys. Okay. We got a bunch of followers today. That's dope.
That's dope.
Let me see. What's up? Diba's here. Diba, you're next. You're next on your question, Diba.
I thought it was me.
I will maybe get to you at some point. Let me see, dude. I've already been streaming for 3 hours. You did one earlier today.
We've already.
You already did one. You did one with the other guy. It's okay. I'll count that if it yeah, Falcon. If you need help with the writing assignment, just like send it over. I'll do a quick review of it. What's up, Diba? You want to come speak? Come speak, Diba, if you want. Or maybe, well, let me tag him real quick. Do. Okay, here, let me see. Ian Stuckey, are you still here, Stuckey? This is a cool little challenge problem. I'll give this like a couple minutes to look at it. if I can't get it, I know this is one of y'all's high level math questions that you guys always do. Hey, here we go. Okay, the sum of 100 given real numbers is 0. Okay, prove that at least 99 of them pairwise sums. That at least 99 of these pairwise sums of these 100 numbers are non-negative. Is this result the best possible one? Not urgent, just for fun. I think it's cool though. I like fun ones. Oh, it's from a Discord combo course that's running right now. That's cool. Penn Center, what are you doing in a meeting, dude? It's 6 p.m., bro. What? You have meetings at 6 o'clock on Monday? Ew. Okay. Sum of 100 numbers is 100 real numbers is 0. Prove that 99 of the pairwise sums are non at least. Do they have to be different? Yeah, department chair. Yeah, dude. Yeah, I know. That's where like all math goes to die. What's a Discord combo course? What's up, Shrey? What's your question? What's up? I'm doing the questions in whatever the order is on the queue. So that's why it's good to post things, in time. Yeah. 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 You're good. Like, I'm just curious. Like, why can't I just do 0 and 0? Oh, well, is 0 a real number? Right? The sum of 100 given real numbers is 0. Okay. So, for instance, if we had, like, I'm trying to think how this works. So, like, 1 minus 2, I don't know. Well, I can't put 1 again, right? Plus 3... minus oh, this hurts my brain, dude. What? I don't know, like plus 49 minus 50 or minus 52? Is that what it is? Is that kind of, if they were all 0 it wouldn't be a problem, but they say non-negative. Okay, prove that at least 100 numbers are non-negative. Yeah. Okay, let's think of it as how does this work? Like if I have n plus, I don't know, n plus 2, and then I'm trying to think of this, like, if this is just some central number, right, that I have. Okay, wait, I see a pattern here. I see a pattern. I think I see a pattern. I think I see it now. Okay. n+1 minus n+1, right? Where these are two different numbers, okay? These add up to 0, right? And then I have like n+2 minus n+2. So for instance, if I just choose n to be, I don't know, whatever, like 10, right? I have 11 minus 9. Wait, that doesn't work. Wait, shouldn't that work? Wait, n minus n plus 1 minus 1. That should go to 0. Right? Oh, one sec. What am I doing wrong here? Oh, 11 and negative 11. Okay, sorry. What am I talking about? Jesus Christ, Gio. Yes. Okay. 100 given real numbers, prove at least 99 are non-negative. Okay. Yes. Okay, I see where. So, okay, this is what you have to do, right? If we have like the sets of numbers, right? I need them to cancel out with each other, right? I need like 1 and -1, and then like 2 and then -2, and then 3 and then -3, so forth and so forth. And then adding all these up together will eventually give me 0. But they're saying that at least 99 of these 100 sums are non-negative. Okay. So I'm going to have up to 50 here and to -50 here. And then at least 99 of these sums are non-negative. So very cool. No, I see what you can do. So, for instance, if this was -49, right? I could pair every number here with like the next one down, and those would all be positive sums. Until I got to here, right? Because then I don't have 0. So then this one becomes the only one that's the negative sum. Okay. And they say at least 99 of these pairwise sums are non-negative. Because then what's the other way you could fix this? Yeah, see what I'm saying? You can do like 50 minus 49, 49 minus 48, so forth and so forth, till eventually you get to, what is it? It's 2 minus 1, and then it's 1, but you don't have 0 left, so then it's -50. So then this is the negative sum, and these are the 99 positive ones you have. Okay. What I could have done is I could have combined 2 of the numbers here and combined 2 of the numbers here. Would that work? No. Yeah, I get to here. I get to how I can prove that there will be 99. I don't know. I can prove that that's the least number you can have. Let me think. At least. Okay, good to see you, Trey. If our numbers were -50, then you'd have more than 90. Well, no, you'd only have 99 positives. But it'll choose the number, so we got to worry about if there are more negatives or if the negatives are bigger or whatever. Yeah, exactly. Yeah. So that becomes a trick. Yeah, right? Yeah. So if I had man. I'm just trying to think. I always like to do like a base case. Let's just do like a low number of cases. Let's just say we have 4 numbers. And I need them. So the easiest way to do this, right, would be -1, 1, -2, and 2. There's 4 numbers. And in order to have at least, I guess, what is this? 3 negative ones, right? I could have 2 and -1. No, we have way more than 99 because, for instance, we can take any 2 of the positive numbers. Oh! Yeah. Wait. Oh, I see. But you're saying with replacement. I see. I get it. I thought that, like, when I break out my sequence into pairs, that, like, I can't do it again. Like, if I do this, I could also do this one, or I could do 50 and 2. I see. Okay. Yeah, well then this is the least, right? Yeah, this is the least, right? So, okay, if we could say at least 99 non-negative. Yeah, okay. Because you're saying with these, right? If let's say I had these numbers, right? Then I could have -1 and 1. I could have -1 and 2. I can have -2 and 1, and then I could have -2 and 2. So that's 0, 1, -1, 0. Oh, but then I can combine them with themselves, right? So I can do -1, -2, and I can do 1 and 2. Right, which is -3 and then 3. I see. Okay, in that case I have 2 of them. Yeah, okay. Yeah, for me I was thinking of like the... Yeah, you can only pin one with the other, but you're right. I can start pairing them within their own sides. Okay. What do they mean, is this result the best? Like, what's the definition of the best? Why is this the best? Why is it the best that I have 99? Like, what are we talking about? What's the best one? Take the first number to be 100 or more and all the other numbers to be negative. Oh, okay. I like that. So you're saying like 100, and then I have like -1, -2, and like whatever I need to do in order to get to 100, to -100. Yeah. Okay. And then, oh, in that case, almost all the pairs are going to be negative, right? Because the only positive ones I'm going to have is this and this. Oh. Take the first number to be 100 or more, and then all of the other numbers to be negative. Then there are 99 positive sums. I like that. I like that. Yeah. Yes, because then 100 is bigger than all the other ones. Yeah, okay. Yes. Okay, I get you. Right, -1, -2. Yes, yeah, I like that. That's kind of cool. Yeah, because then all of these sums will be positive, right? As long as this like adds up to -100, which it can't, right? This would have to be more than 100. What is you know, this is too funny. Taco Cat, this goes back to what we were doing with arithmetic sequences, right? You remember when we were doing arithmetic sums? This is why this is related, right? So if I have where is it? Yeah. I can figure out what number I would need if I need 99 other numbers to add up to it, right? So let's say it's -1 plus negative 99. Oh, divided by... Oh, I don't like that. Oh, yeah, divided by... Yeah, wait, it's the average divided by 2. Yeah, okay. Times the number of terms. Sorry. Is it n? Yeah, it is n. It's n. Oh, but the number of terms is 99. Okay. So that's negative 50, right? Times 99. Okay. So that's what you need. Negative 50 times 99. Right, okay. So you need 4950, and then you need negative 1, negative 2, blah, 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 all up to negative 99. Okay, cool. Yes, and in that case, you have at least 99 positive sums, because this can make 99 pairs with things. Oh, very cool. They didn't say unique numbers. That's true. Oh, I see. So you're saying I could just do 99 and then negative 1 99 times. Okay. Same thing. All right. Yeah. I see that. Okay. So wait, how do I prove that though? This is always my question of this is where math proofs get kind of weird, because I'm like, okay, how do I prove this though? Do I have to do like a proof by induction or something, or I don't know, like find the contrapositive? It's a cool question. It's a very like math puzzly question. Yeah, I like this. And yeah, I needed some clarification with like, oh, you can make all the pairs on the inside as well. But yeah, what does the best mean? What is this result the best one? What does that mean when it says the best one? Okay, let me see.
Nice.
Wow, thanks again for the follow, Miranda. The way I read it is like, can you replace 99 with a bigger number? Oh, so could you have more than 99? It is a little vague. Yeah, it is a little vague. Right. Can you have more than 99 positive sums? I don't know. Can you? Wait. Yeah, you can. Right? Because, yeah, for instance, in this case, right, I could have this be, let's say, what is this? 99. Well, no. Say 98. No. Yeah, no. 96 to
Nice.
98. Yeah. And then negative 1. Good. Negative 1, blah, 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 blah. 98 times. Okay? Yes. And so then I have, right, I have 97, wait, 99. Yeah, I have 98 positive combinations of this and 90, wait, no, I have 99 positive combinations here and 99 positive combinations here. Yeah. Yeah, this is, yeah, okay. So yeah, I think that's the minimum. The devil can make you fail. Who's this math devil that's messing with us, dude? Okay, cool. I'll count this one. I think we can basically finish this one. That's a cool one. I appreciate it just being like tricky. Nice. Okay. Let me see. Who else had questions? Ethan had a question. Oh, Teacup's gone, I think, right? It's 9 p.m. for him. Did Deba show up yet? Is Deba back? Where did Deba go? I don't see Deba. He was in the stream, or in the channel. Okay, Ethan. Ethan, you want to do yours real quick? I do eventually. I've been streaming for a while here. What? We're at 3 hours and this. I think this is the longest stream we've done. 3 hours and 24 minutes. Yeah, you're welcome. I like the question, Ian Stuckey. That's really cool. No, it's a very cool question.
Hello? Can you hear me?
Yeah. Here, do we have your, does your channel? Yeah, there you go. Yeah, shout out Ian Stuckey. Ian Stuckey's got a really cool stream, and I saw you had an announcement. You're starting a new streaming schedule, I think. Let me see. It's in the Elements, I believe. Where was it?
The Elements, yeah.
Yeah, the Elements is this channel. So, yeah, where was it?
I'm in there, yeah. I'm in there.
Yeah, this is very cool. Yeah, so Ian Stuckey's a great person that also streams Math Help. And cool, you're going to have a new community schedule. Yeah, my schedule is pretty set right now, so if you guys want to throw whatever mine is on there, because I know, yeah. Oh, you already have it. Oh, thank you, Penn Center. Or whoever did this. Yeah, great. Good job. Yeah, okay, so this is cool. This is the schedule of all the different math streamers and when they stream. Yeah, thank you, bro. Yeah. So if you're ever looking for Math Help and I'm not around or I'm busy with other students and we're streaming, please check out all the other wonderful math streamers we have in the schedule. We should have a way to somehow display that. I'm trying to think how we could do that. Yeah. I hear a JBL soundbox in the background.
Sorry.
Is that you, Ethan?
Oh yeah.
I
I'm
hear
trying
your
to see if I
good
could. I'm trying to connect that. That's it.
It's okay. Yeah, I hear it. Okay. What's up, Ethan? All right. Discord sucks for displaying a table. Yeah. Maybe we just need like an image, but maybe like a link to an image, or just put it on a Dropbox or something. Or I'll do it. It's okay. I'll have like link to schedule, and it'll post to it or something. Yeah. Okay. Which one do you need help with, Ethan? What's up? Which one do you need help with?
The third one.
Okay. Are they asking you to find the area of the blue section?
I guess so. That's like the shaded region, as I can assume.
Okay, cool. All right. How do we do this? How do we find the area of the shaded region?
Well, I think how you start off is that since they're not giving you the since they're not giving you it explicitly, you got to since a circle is 360 degrees, you gotta
full
use
circle 360. What'd you say?
It's like 360 minus 45 degrees.
Yeah.
Since you want to find the area.
Good. Yes. That's 315 degrees. Yes. Right? Cool.
Yeah.
This is 315. All right. Then what do we do with this?
And yeah, I think you gotta plug that into the area of sector formula, right?
Yeah, area of a sector. What's up, Sensation? Good morning to you. Which is what? What's the area? What's the equation for this one?
So see, I think hold on, what was the area of a sector again? I think it was pi over 360 times. Sorry, I mean theta. I keep getting on mixed up. Theta over 360 times pi times. Yeah, theta over 360 times pi times r squared, right?
Yes. Yeah. Good. Again, this is the percentage of the circle, and then this is the area. That's why this should make sense to you guys.
All right.
Okay. So you can do this.
We can substitute the values in.
Yeah,
so
315 over
we
360.
we obviously know. Yeah, and then pi. Well, they don't specifically tell me what to use for pi. Like 22 over 7.
Oh, you can just use a calculator for, or 3.14 always works. Yeah. And then I think this is the radius they give you. It's the 6.
Yeah, that is the radius. Yes.
Okay. Nice. All right. Let's calculate some things. What's this? 315 divided by 360 equals that times pi times 36, and that's going to give you 98.96 centimeters squared. Nice.
Why is it always centimeters squared?
Why is it centimeters squared? Well, it depends on what the units
Yeah.
are. So since they gave you the radius in centimeters, it's actually kind of a cool thing. I know I hated units when I was your age. I was like, fuck units. But they're actually kind of useful. This radius here, right? This is pi times 6 centimeters squared. When you square something inside of parentheses, you technically square both things, right? Remember if we had like a squared b to the third? What would that become?
In the laws of indices, isn't it just like the little number is multiplying by itself outside, and
Yeah.
yeah, you're supposed to do 2 times 3 and then 3 times 3, right?
Yeah, good. So it's a to the 6, b to the 9th, right? You do the same thing here with units, okay? This hits both things. So this becomes pi times 6 squared times centimeters squared, which is why this is 36 pi centimeters squared, or they say square centimeters.
Okay.
Okay. It's very useful. Like when we start doing other classes in physics and whatnot, units kind of help you figure out what the formula is too sometimes. So if you know, for instance, that I don't know, like I need newtons, then I know I need, okay, cool, I need something with kilograms and meters per second squared, and you can figure out the formulas.
Right.
Yeah, it's very useful. I can show some examples of that later and stuff. But nice, good question, Ethan. Dude. Glad you got it. Ethan. Yes, good. Coins at Ethan 2000. And then there we go. Weekly question. Cool. Awesome. Great. All right. Do we have any more questions? I think we finally got through everybody's. Besides dude, what was it, QV, dude? What'd you ask me here? QV asked me to do this. Dude, I cracked up, dude. It's too funny. 3 hours and 30 minutes. Yeah, all right, cool. All right. Thank you, everyone, for coming to Office Hours. Had a great time. Stream with all you guys.
That's dope.
Record stream, 3 hours and 30 minutes. Wow. Appreciate all the raids. Ian Stuckey, I think you really, like, popped us up to a certain threshold, and once we hit that, we hit whatever the front page of Twitch is, which is great, because that's why a lot of people start finding us through Twitch. Which is awesome. Cool. All right, our next stream is going to be tomorrow, an hour later. That's going to be at 4 p.m. Pacific, 6 p.m. Central, 7 p.m. Eastern. So if you had to leave and I couldn't get to your question, because I know it took a while. I know some of you guys were waiting here for like an hour, 2 hours. Come by tomorrow's stream, and I'll help you out with it. Or just make sure you post your question early in the queue. And then make sure you're here when I say that we're going to go over your question, because if you're not, I gotta keep moving to the next student. I really do. But okay. So yeah. That's going to be tomorrow. Let me see. Is anyone else streaming right now? Can I raid someone? Someone doing some stuff? Yeah, Danny Highway, dude.
I need to ask you something.
Danny's answering questions too. So here's the thing I do want to do. And I got to talk to the other mass streamers about this, but if, for instance, the times I'm streaming doesn't work for you, or we're running out of time to do your questions, I want you to still be able to get credit for asking questions on other people's streams. I need to make sure it's okay with them first, so I don't have all you guys like I don't know, bombarding them with questions if they don't want to do them. But I think what I'll do is I'll allow you to do that, and then if you clip them going over your question, then it'll count for the credit. But okay, cool. All right, we're gonna go raid Danny. He's a cool guy. I like Danny.
I want to ask you one thing.
What's up? Ethan, what happened to you? What happened to your stuff? Oh.
I was using a JBL speaker above all other speakers. How did you know this specific?
Oh, because I know the sound. Anyways, okay. We're going to go raid Danny. I will see you guys later. Peace out. Enjoy the rest of your Monday. Hope it's great.